Good evening, folks. We're going to have a two-part show, and in the middle of it, we're going to do a chat with a few of the usuals, the usual friends. I hope you enjoy the show. This really opened my eyes to how academia science reacts to new discovery. It's a great series. I hope you enjoy it.
Beginning was the Big Bang. We are told that 13 to 20 billion years ago, everything that makes up the universe as we know it was spontaneously created out of nothing through an unimaginably violent explosion. But did it really happen as we are told? A growing number of astronomers doubt it and are showing why. This is their story, the story of the universe.
The observational aspects of trying to understand the universe, I think it's reasonable to start about 100 years ago. And about 100 years ago, almost everybody in astronomy, without question, assumed that the whole of the universe was what you could see in the Milky Way. Nobody felt that the universe was any bigger than the stars that you see in the sky, associated with our own local Milky Way. And that was the situation certainly around 1905, times like that. There are well-known people who propounded these ideas. 10 years later, Einstein first proposed his general theory of relativity. Now, when Einstein proposed this, it's a theory of gravity, which means that it's a theory which should represent the whole of the universe, because it's gravitational forces that are controlling the universe. Well, Einstein made this theory around 1915, and he immediately wanted to try and use this theory to explain the universe as it then was, the so-called Milky Way system. But of course, the idea of this was that it was a static system. That is, it wasn't contracting or expanding, it was a static system. And Einstein found that his equations did not allow for a static universe unless he inserted a certain constant in the mathematics, which became known as the cosmological constant. But what happened in the early 1920s was that a very clever Russian called Friedman in 1922 found solutions to Einstein's equations which allow the universe to either expand or contract. Now that was done in the Soviet Union soon after the revolution, and nobody in the West knew about this, I think. But in 1927, a Belgian priest, the Abbé Lemaitre, as he later became, also discovered these solutions. And he
was trying to figure out electricity.
And his work was publicized in Cambridge and elsewhere, and the famous English astronomer Sir Arthur Eddington and others got to know about this, and they immediately began to say, how can this apply to the current universe? Well, in the same period, in 1929, Hubble made what I still believe was the most important discovery in extragalactic astronomy in the last century, or the last century but one. He showed that if you look at the spiral nebulae the faint spiral nebulae, the shifts in their spectra are proportional to their apparent brightnesses. And this led very soon to the idea that this fitted very well with the expanding universe, and that indeed this is the kind of universe we lived in, that what we were looking at are galaxies, Milky Ways, further and further away from us, and the further away from us, the larger the redshifts, and if that's interpreted in the way that most people would interpret it, this means that they are moving away faster and faster. So this was the original idea. By the 1930s, the front page of the New York Times said we live in an expanding universe.
When Hubble made his great discovery, it was for galaxies like our own Milky Way galaxy, and they all followed the same rule, that the fainter they are, the larger their redshift. In other words, the faster they are moving away from us. This is known as the Hubble law, and directly led to the expanding universe theories. But in the 1960s, there was a new discovery, the quasi-stellar objects, often referred to as quasars. They appear as star-like points on the sky, frequently blue in color, and they have very, very large redshifts, implying that they are at huge distances from the Earth, at the very boundaries of the observable universe. Some astronomers soon found that a vast number of these strange new objects populated the regions around spiral galaxies, and were not only observable with radio telescopes, but were optical and X-ray sources as well. There were two properties of the quasars that were difficult for astronomers to understand using the expanding universe theory. The first was that if one plotted their apparent brightness against their redshifts, as one does for galaxies, one gets an unexpected scatter on the diagram, instead of the smooth curve made by the same plot done for galaxies. This seems to indicate that the quasars do not follow the Hubble law as do most other objects, and that there is no direct indication that they are actually at their proposed redshift distances. In fact, it is argued that if Hubble had first been given the plots for quasars, he and other astronomers would never have concluded that the universe was expanding. The second property was that quasars are very small, compact objects, sometimes only a light year across. So if quasars are really at their extreme redshift distances, they must then be the brightest and most energetic objects known to astronomers. So energetic, in fact, that untestable, almost metaphysical mechanisms must be applied to explain the phenomena. On the other hand, when placed at their observed distances, that is, in the neighborhood of nearby galaxies, their brightness and energies become normal, and no special mechanisms need to be evoked. This problem has led many astronomers to abandon the idea that all redshifts are due to their speed of recession away from the Earth. And if this is true, then there is no need for an expanding universe, and the Big Bang never happened. Questions arise. Is there a connection between certain types of galaxies and the quasar? Are quasars ejected from galaxies, and in fact proto-galaxies themselves? Is there some other astrophysical process which can explain the redshift discrepancies? One of the world's most controversial experts on the structure and morphology of quasars, Halton Arp, has for 35 years proposed just such an idea. For the heresy of opposing orthodox interpretations of the redshift problem, Arp has had to pay a heavy price. the same price paid by many a scientist with new and innovative ideas. Dr. Arp was forced to resign from his permanent position at the Carnegie Institute of Washington Observatories after the Caltech head of the Telescope Allocation Committee threatened him by saying, unless he changed his line of research, they would take away his telescope time. Due to this fact and his ongoing struggle against the established paradigms, Arp is often referred to as the modern Galileo.
I remember when I sent the paper into, the first paper into Astrophysical Journal on the nature of companion galaxies, and I had a lot of them on the ends of spiral arms, so I was sure that they were connected, and I showed that they were systematically redshifted. I sent that in with naive, great expectations that people would be terribly interested and impressed on this. And the editor of the Astrophysical Journal at that time was Subramanian Chandrasekhar, who had a fantastic reputation as a master theoretician and also quite an incomprehensible theoretician, and a tremendously powerful figure in the field, and editor of the Astrophysical Journal, which was probably the most powerful position in the field. And he chose not to, in his wisdom and judicial fairness, chose not to send it to a referee, but he just wrote across the paper, "This exceeds my imagination," and he sent it back to the director of my institute, Horace Babcock, with the obvious implication, you've got to do something about this staff member of yours who's doing these very bad things. And so Horace called me down in the office one day after this, and I walked in his office, into the director's office, and I saw this paper lying in front of him with Chandrasekhar's scroll across it. And Horace looked at me and said, well, he said, this is just too much, and you're going to have to start looking for another job. And so all I could say to him was, well, if you send me that in writing, please send me in writing. And I was waiting in great trepidation for weeks and months to get something in writing, and I finally never did, so I realized that he decided to give me another chance, so to speak. So that was fairly early in the game, and then some years went by, and there was the competition for time, particularly on the 200-inch telescope, was getting more and more heated, and people were saying, well, we can't continue to give time to this obviously incorrect and embarrassing research that Arp does. So finally they sent a letter to me from the allocation committee, including a number of the younger members of my institute, saying that unless I changed my line of research, that they would have to take away my telescope time. At that point I considered the situation very carefully, and I figured that the evidence, although a lot more evidence could be gathered and has since been gathered since then, the important thing was not the evidence, because if it was true, it would come out someday. The important thing was the principle of scientific investigation, whether scientists could follow new lines of investigation and follow up on evidence which apparently contradicted the current theorems and the current paradigms. And I also felt that regardless of what happened to me personally, that this was the important issue, and that I had no choice but to resign on the point of this issue, so that if it developed, which I thought it would, that my line of investigation was correct, that people then in the future would say, okay, this was the wrong thing to do, and in the future we're going to have to see that this kind of thing doesn't happen again.
The observers come in now with the belief that we live in a Big Bang universe, and therefore all of their ways of understanding things are tailored to that. And they don't come in with the possibility that this that our alternative, or any other for that matter, is right, and really do it in an open-minded way. And of course what goes along with that is that observers who would like to test this way find it very hard to get observing time and so on. I mean, this relates to the whole issue of whether the complete lack of balance in the way the observational programs and the funding are conducted. There's no question about that. I don't think that anybody would argue about it.
I've always said that the cause of the troubles is the American graduate school. You get one person who then lectures to his students in graduate class, and because you have a system, you see, when we had graduated first degree, we were independent. We could thumb our noses at the professor, and in fact the best way to get ahead was to do something that the older people didn't agree with, and to be right. That was the way to do it. And but in the graduate school, you all have to learn what you're taught, what the professors are teaching you, and then those people go out and get jobs, and they have another graduate, their own graduate school, and it just tier after tier. You get a few places like Caltech or like Harvard, and they set the fashion for every place.
I think there's a problem with graduate education. I think graduate education is not teaching students to think, to be independent researchers. I think it's teaching them to be part of a scientific society. And too much, especially students that are at the so-called elite institutions, I think they're taught too much the paradigm of their advisor.
All of us, whether or not we served in uniform, are veterans of a war in which freedom and free government are at stake. Such fullness of knowledge is the direct function of education. Most of us work hard to provide our homes with every possible comfort for our children. We safeguard their health. We strive to set before them good examples of moral living, of manners and deportment. Possibly we even pamper them. Yet complacently, even carelessly, we commit our children to schools of which we know but little. We cannot meet the complexities of modern life with outmoded school systems. We must keep our educational standards abreast of the swift-moving times in which we live, if we hope to preserve our national heritage and our American way of life, the American way.
When I was director of the National Observatory 20 years ago, there was a very well-known astronomer now. In fact, she's just won the Cosmology Prize. That's Vera Rubin. She was carrying out a program at Kitt Peak at the National Observatory of observing faint spiral galaxies with a view to looking to their redshift distribution, their velocity distribution. And this was a program that everybody thought was a good program. And so she'd been given observing time, and at the end of about a year, she had completed about a third of her program. And so she actually wrote a little paper pointing out that she was getting results very different from the ones that were expected. And we had our usual meeting, and when we got to her program, which was an ongoing program, so people just looked it over, the leading extragalactic astronomer on my committee of that day immediately said, well, look, she's getting this result. It doesn't fit. It has to be wrong. I recommend that we stop the program. That was his position. And what was interesting to me was I sat there and listened to this discussion. And the majority of the people, because of his level of knowledge and authority, went along with him. So the recommendation of the committee was that we stop the program. Well, I had the last word, so I ignored it. But most people don't.
They ended up creating dark matter
itself,
to
which is
explain
very
it.
conformist, will always do just that. That's one of the reasons why the road ahead is hammered out. As Hoyle said, anytime you point a new telescope at the sky now, you're only going to find what you already know is up there.
I have a lot of trouble with the academic world, the same as I do with the Bible Belt. It's the same kind of trouble. It's the same kind of trouble. It's because they get a picture of this world which they are sure is right.
Yes, yes.
And they hang on to it for for all they're worth. But, you know, I often point out that I am probably more unorthodox than anyone who has ever burned at the stake. It's illegal now.
Illegal burning.
It's illegal now to burn somebody to the stake in your backyard.
Peculiar galaxy NGC 7603, discovered 30 years ago by Halton Arp, is one of the more striking examples of galaxy-quasar connections. It has recently been re-examined after the discovery of 2 new quasar-type objects embedded in the connecting filament. The renowned optical astronomer Margaret Burbidge has for decades been a central figure in the struggle to bring controversial observations such as NGC 7603 to the attention of conventional astronomers. And for her fairness and untiring efforts in the field, she has become one of the most widely respected women in astronomy.
There's a very interesting galaxy known as NGC 7603. It's a Seyfert galaxy. That means it has one of these active nuclei with strong emission lines and a lot of activity, obviously, going on in its center. And it was studied years ago by Chip Arp in his Atlas of Peculiar Galaxies. It has a spiral arm that seems to come right outside of the galaxy, trailing right out, and it ends up on a fainter galaxy, but it ends right up so it's connected the nuclei of the 2 galaxies.
In the Atlas of Peculiar Galaxies, which was published in 1966, that was the point of the atlas, and one of the objects, just to illustrate what a peculiar galaxy is this what is now famous NGC 7603, and this is the central Seyfert, which means just a very, very active galaxy with a lot of energy in the nucleus and a lot of explosive energy and so forth. And here's the high redshift companion here, and you see it's joined by a filament, a material. It turns out from the observations that this filament of material is material of the galaxy, gas and dust and stars and so forth. It's been drawn out in the ejection. But the astonishing thing, and the controversial matter, is that this galaxy is a much higher redshift than this.
Now, NGC 7603 has one redshift of about 8,000 kilometers a second, and the other galaxy has a much larger redshift. So how can they be connected? Well, these data were published years ago, and everybody said, well, this is just a chance location of a background galaxy near an interesting foreground galaxy, and that spiral arm has nothing to do with it. It's just the whole thing is just a chance.
If you see 2 objects close together with very different redshifts, you only have one of 2 explanations. One is, as I say, that a large part of the redshift has nothing to do with distance, and the other is that it's an accident. So the real issue that you come down to is how frequently do you expect to see accidents?
If you look carefully at the pictures that were taken of this field, you will notice 2 faint stellar objects that are in that spiral arm. One is close to NGC 7603, and the other one is close to the faint companion galaxy.
In the year 2001, when the 2 young Spanish astronomers worked on this with the Las Palmas telescope, they saw that there were these 2 condensations, stellar condensations. They looked like quasars, but everybody would have said that they had to have the same redshift as the central galaxy because they were obviously in this filament that had been ejected. What they found was that each of these objects had a much higher redshift, and that the filament itself had the same redshift and spectral composition as the galaxy from which it was ejected.
And they got some spectra using what's called the Nordic Optical Telescope in the Canary Islands on La Palma. It's not a very large telescope, but they got some excellent data, and they got spectra of these two faint objects, one by 7603 and one by the companion galaxy, and believe it or not, they showed that both of them were quasars. Not very high redshift quasars, but definite quasars.
Two of these quasars. Now this one will turn out to be quite good. But it's very nice.
It's a fairly big blow-up. This is a couple of months, I think, across. But it looks like it's extended.
Anyway, it looks redshift.
So we'll go ahead and move it and then narrow it up.
The chance to have many quasars around a galaxy as a background objects. Of course, you have some chance, but these are very, very low, and this is what should be answered. This is what should be answered. NGC 7603 is a very special case of this correlation. You find not only three objects with different redshifts in the neighborhood of a major, safer galaxy. You also find the filament connecting all of them. So this is more important because the probability to have all these objects, not only in the neighborhood, but exactly in the filament, is extremely low.
The galaxy, which is an active galaxy, two low redshift quasars, and another galaxy with twice the redshifts. In other words, you had four objects all connected together, apparently, by a luminosity, by a luminous bridge, each with a different redshift. Now that, I would say, is pretty conclusive evidence for the existence of non-cosmological redshifts.
We were lucky because we have found that the object has more controversy than expected. If in the past Chip Arp thought, and Barbies and other people that have dedicated some effort to research this object, if they thought that there were two objects connected by a filament with different redshift, now we have discovered that there are four objects all connected by the same filament, and all of them with very different redshifts. So the Doppler redshift area is discovered.
I think they have to look at it, and I think it's one of the most striking results that we have available. How they can make sense of it other than saying that these objects, that these redshifts of connected objects that are the same, more or less the same distance from us, that these redshifts have non-cosmological components to them.
The topic of the anomalous redshift is very important for most of the areas related with cosmology and extragalactic astronomy nowadays. If we assume, as it is done nowadays, that all the redshift are pointing the distance of the galaxy or the quasar or whatever, of course the results will be very different than assuming the other thing, that the redshift are due to other reasons. The distance of the quasars and the galaxies will be different, the energies involved in the process will be very different, so a lot of astrophysical processes will have to change.
Conclusive evidence that the expanding universe was not correct, and that the redshift distance law was not correct, and that we had to have some way of creating new galaxies with high redshifts.
It is normally argued that the Big Bang, for instance, the Big Bang cosmology, is against the anomalous redshift question. And of course, the Big Bang theory is the most important theory that we have nowadays to explain all that we know about cosmology, which is not too much, in my opinion.
There's a large body of work going on, observational work, theoretical work, which is based on the assumption that quasars are at their cosmological distances. If it turns out seriously that we're right, then all that work is in vain. we don't know anything like as much as we think we do by saying that the quasars are far away. And that's another huge problem for people to face up to.
One of the frightening things, I think, for conventional astronomers is to accept the fact or to realize that these intrinsic redshifts for the quasars and peculiar galaxies and so on, active galaxies, means that a lot of the things which we thought were out at great distance in the universe are very much closer in. And in fact, you would have to say that what we call the local supercluster is much more crowded and contains many more objects than we previously thought. And then the question comes up, well, what is out beyond the local supercluster, and can we with any certainty identify any objects that are out there?
Be aware of what of our interpretations, because we cannot distinguish which objects have cosmological redshift and which objects have non-cosmological redshift. Then we cannot trust the redshift indicator as a distance indicator.
People who work on the origin of the universe, they ought to look at data of this sort, because they've got to understand this. And I've heard good friend astronomers say, well, there's more out there in the universe than we understand.
What's really happening in these systems is that the centers of the galaxies are the places where creation is taking place rather than just in a big bang. And so you're looking at all these mini bangs where matter and energy are actually literally being created. And this is an old idea which is not ours. Originally it was due to the very famous Armenian astronomer Victor Ambatsumian, who only died a few years ago, who also argued that galaxies which appear to be coming apart and objects that are coming out of them are coming out of them. Very simple idea, but Ambatsumian, who was a very well-known theorist, always said you must look at the observations, and maybe if things are coming apart, appear to be coming apart, maybe they are coming apart. Conventional astronomers don't allow things to come apart. They always say there's enough dark matter in the system to hold it together.
I've come to the conclusion that what it is that will unseat an established prejudice, a strongly established prejudice, is one observation. One single observation, usually a very simple one.
The conclusion was very, very strong just from looking at this picture, that these objects had been ejected from the central galaxy and that they were initially at high redshift, and the redshift decayed as time went on. And therefore we were looking at a physics that was operating in the universe in which matter was born with low mass and a very high redshift, and as it matured and evolved into our present form, that we were seeing the birth and evolution of galaxies in the universe.
If proto-quasars, ejected from the nucleus of active galaxies, themselves evolve into new, younger galaxies, astrophysicists must find experimentally and observationally the mechanisms which describe this phenomena. One model explains that the proto-quasars are ejected, trapped in the galaxy's extreme magnetic field, aligned along the spiral arms, thus explaining the torn, disturbed features often observed in the galactic medium, and the frequent appearance of high redshift companion galaxies attached by filaments to a lower redshift parent galaxy. The other and most frequently observed alignment is when quasars appear to have been directly ejected out of the galaxy's active nucleus along its line of least resistance, creating a field of systematically high to low redshift quasars, or younger to older evolved protogalaxies. This is exemplified in innumerable systems like the one around the galaxy quasar field of NGC 3516. If one disregards the proposed redshift distance to these objects, observation clearly points to ejection as a likely explanation for their close vicinity to the central galaxies around which they are found. These results, though preliminary, are promising developments which may lead the way to new and exciting insights in cosmology.
One of the best and earliest of the really controversial things was a Seafoot galaxy known as NGC 4319, which Chip Arp discovered that it has a protrusion coming out in the south direction from it, one of its spiral arms, and ending up on another galaxy known as Markarian, and people have tried to explain it away in all kinds of ways and then tried to take false pictures to show that it's not there. But I've seen the good pictures, which were the first really good pictures were taken by Jack Sulentic.
NGC 4319 was part of some work that I did in the early 80s when I was a young astronomer, a young faculty member, and people were coming up to me and saying, oh, I've written a paper to show that what Chip Arp has done is wrong. There were at least 3 famous papers right around 79, 80, 81. And it took about 5 minutes to look at these papers to see that they were flawed. And one of them was a paper that claimed to show no connection between NGC 4319 and the Quasar, Markarian 205. So at that time I had the opportunity to work at JPL using the new image processing facilities that had been developed for the Voyager program, in fact. And it took 1 hour's effort to show that there was some kind of a luminous feature between those 2 objects. I don't know what it is, but there's no question that there is a luminous feature, and it cannot be dismissed in the ways that it was dismissed in the early 80s.
Suddenly there appeared press releases from Space Telescope Science Institute, which was the research arm of NASA's Hubble Space Telescope, and this press release said that they were not connected, and it gave a Hubble Space Telescope picture. It was not very deep, and you could just see 2 objects and no connection between them. And in this press release, then they said that that this proved that there was no contradiction with the current expanding universe paradigm.
No connection between the 2 objects. So I looked at their picture, then I downloaded it, and it took me 5 minutes to show that it's still there. Now, I don't know what it is, but I think you face up to the existence of the feature and then you consider conventional and unconventional explanations. But I was really surprised that they felt it necessary to issue a press release saying, it's not there, it's not real. It's the same thing we saw 20 years ago.
But it's hard to get people to look at this because they don't understand it. You see, it's again the non-cosmological redshifts.
We realized that the people who had been processing the pictures and released it must have known that the bridge was there, and yet they chose to try to convince the public that that in fact it wasn't there and that everything was right with the current expanding universe paradigm.
It's a strange attitude. I don't understand it as a scientist, really. I think that news release could have generated much more interest in astronomy than many of the more conventional news releases, because people would be talking amongst themselves, gee, what could that be? And then various people could offer scientific explanations. But to just sort of close the door, in a way you could argue that Chip, or someone like Chip, who believes in an alternate interpretation, I'm sitting in the middle of the bridge, so it could be either way, he should feel strong, because I interpret that as a manifestation of fear and uncertainty. Because if I really had confidence in my paradigm, I'd put it right out there and say, well, yes, there is a bridge there, but it's either this explanation or it's that explanation, but certainly it's not what Chip Arp says. but instead to just say it isn't there. That's a manifestation of fear, I think.
Coward.
This misrepresentation of the results on a public level, published through a press release from a government-supported institution, which was not refereed, in which
I'm sorry, it's just obvious.
Seemed to escalate, in my opinion, and my colleagues' opinion, escalate the controversy into a publicity campaign, which was sort of like doing scientific research by press releases in an attempt to defend, as a sort of a last resort, a dying paradigm in physics.
I don't know what more one can do than the data are there, they've been got, we have to make sense of it.
I think in one sense they think it's bad to, quote, confuse, unquote, the public. Because if you believe in the standard paradigm with all your heart, you know it can't be real. I know it can't be real. You know, if I try to be at all rational within the context of the current Big Bang ideology.
So if you have a cosmological theory that actually starts somewhere. I mean, I knew this when I was 10 years old, I think, sitting out in the backyard swinging with my brother, thinking about what would the edge of the universe look like if we got to the edge of the universe. And we, both of us, realized, even at that age, that the notion was somehow did not make sense. The universe can't have an edge, and it can't have a beginning. Because if it had an edge, there'd have to be something on the other side, right? And if there had a beginning, there'd have to be something on the other side of that. And somehow, cosmology, a satisfying philosophical cosmology to me, would have to start with that notion that it was always this way, and it always will be this way. There's all kinds of things happening in there, but somehow the basic laws of nature are such that this exists.
Of course, this is astrophysics, this is science, and everything can be refuted. You have an explanation, you can produce an opposite explanation, so not everything is not so simple.
The theoreticians ought to be really looking at this theoretical problem, and the observers ought to be gathering much more data of the sort that we get. But I think they're all a little scared because it's an unpopular subject. They're worried about their jobs, and they're worried about getting moving on up the ladder. You know, if they're postdocs.
A young person in academia cannot afford to go against the Big Bang. He'd immediately lose his position, tenure. Tenure now. As I said last night. And so there is this difficulty. You can't expect him to do that.
Don't collaborate with Chip Arp, or don't collaborate with Geoffrey, because if you do that, you will have problems to get a position in such a place. I received such a blackmails.
When I was a student, I was naive, and when I saw the chance to work with Chip Arp, he sent me a letter. This is 30 years ago, in fact. Good heavens, I hate to even think that it's 30 years ago. And warning me now that you may find some people put off by an association with me. And I didn't even understand what he was talking about. I thought, I'm just trying, we're just looking for the truth, aren't we? We're just investigating other areas, alternatives. But I found, indeed, that it was not this way, and that there was a great deal of hostility.
In my opinion, even if we are wrong, I'm not saying that we are right or anybody is right. From an observational point of view, we have a very peculiar object. So, and this peculiar object, it deserves some further research. This is what we need. And the interpretations are free and are to be discussed.
Now we're entering the realm of cosmology, and it is here that religion, philosophy, metaphysics, and science all meet. And make no mistake about it, they all play a role in our beliefs. The amount of data that we actually have to support any particular model is small. It's mostly consistency arguments. We can argue that the 3-degree microwave background radiation, yes, it can be explained within a Big Bang context, but I believe Fred Hoyle and Jan Harlekar and Jack Burbidge have suggested an alternate explanation. And I'm sure we could find 10 more if the need were felt. But strangely enough, it's not. You don't get tenure in a university, you don't get promoted, you don't get recognition by looking too much into unpopular areas.
Cosmology is not a science. Has a lot of scientific aspects. We can know many things with the science. We can know how the galaxies are distributed, and this is our measured with the observations. We can know how rich are how many metals are in the intergalactic medium or in some galaxy, and all these aspects are scientific. But with regard to some considerations about the beginning of the universe, this is in some way crossing the barrier of the science and going to something in between the science and metaphysical speculation, in my opinion.
Sociology is very important in science. People are in groups and gangs and cliques and clusters, and of course that enforces conformity. You want to be one of the boys, one of the dare I say, one of the girls. It's the same after all. And so you tend to think alike. The longer you're together, the more you will think alike. I remember one famous group once, I asked them, how do you resolve disagreements amongst yourselves? And the reply was, we vote. And I thought, what a strange thing to do in science. Vote? I would think the best thing is that all 7 of you disagree.
Consensus science.
That creates chaos. And the argument that we need some common thread or road to follow, for the majority to follow, in order to have some kind of organization to the whole scientific enterprise, there is an argument for that. But when it becomes all-encompassing, so that no other possibilities can even be explored, that is not good. And we're there.
Scientific notions take on, they have a lifetime that really is involved in it gets involved with like somebody's job. It gets involved with, my theories are all in this particular, support this area. And so I don't want anybody in my department actually who doesn't work in that. I wouldn't want somebody in my department who is working in a very different side of things, like the steady state Big Banger kind of thing. If you were a steady state person, at this point you're feeling a little bit, paranoid anyhow, because most people said, hey, they found, Penzias and whoever he was, Arno Penzias, and the guy found there was the sky wasn't dark. There was a tiny little bit of light.
The cosmology as a science has begun 1 century ago with Einstein's theory. So in 100 years, you cannot produce a theory of everything. This is crazy. Even from a philosophical point of view, historical point of view, we have begun 100 years ago. In 1920, we thought that the Milky Way was all the universe. And now you want to produce the belief that in 80 years or something you have produced the theory of all the universe from the beginning to now. This is somewhat incredible and not very objective.
The Big Bang is predicated on the assumption that from a point of view of physics there are no surprises in store for us, which is very unlikely.
When you start using words like infinity and perpetual and steady state and all those kind of things, you're really using a vocabulary that was formed here in a quite limited sort of part of the vastness of everything, right? I mean, we developed that vocabulary as a way of finding food, mates, building shelters, that sort of stuff. We didn't develop that vocabulary from vast knowledge or need to know about how the universe works.
We're at the level of where the observations are clear, in my view, but the theory is not. And one of the things that you find in science, and particularly in astronomy, is that people find it very hard to believe in observations if they don't have a theory, if they don't have a theory ready to explain it.
We also need theoreticians. Observations without any theory don't work. And theory without any observations certainly don't work. And the problem is to get them together. The problem is to get them together. We need some glue.
To anybody with an open mind, that should really prove the case that that quasars are associated with galaxies at much ordinary kind of redshifts, while the quasars have higher redshifts. Therefore, they must part of the redshift must be non-cosmological, not to do with the expansion of the universe.
Because I'm always thinking, if we can only be more rigorous, they will believe us. But I was wrong. I was very naive. It's got nothing to do with that.
The rolling of the Big Bang, it's largely been determined by the way people seized upon these ideas, and there's been tremendous amount of propaganda making claims that here we see everything happening and this has to be right.
The people that are in that field treat it like a religion.
And not very objective.
The reaction of the Orthodox astronomers to this idea is that it violates the Big Bang assumption, the Big Bang hypothesis, and therefore it cannot be true.
The amateurs tend to be more broad-minded than the people who have to earn their keep by being narrow-minded. I got it.
Was this worked out by somebody, or was it, did it just happen by chance? Which is really the same thing as saying, did the universe happen by chance? And I have to say, when I look at it, it doesn't look to me at all like chance.
That's a great show. Yeah. The second one gives you even more insight. Eye candy isn't as much, but it's just as important. So, most likely, to me, the universe isn't expanding. I don't think it's expanding. I think that's crazy talk. And just like the black holes and all that, it's just a lot of crazy talk. They can't prove any of it. Like Walt Thornhill said, I believe that what they think that black holes are plasmoids. And it would really only make sense if the universe was biological. Because we are. Everything is. Trees have seeds. Everything. Why wouldn't galaxies? How else would they have been formed? I'm in the Great Hall. I might be there for a few, and then I'm going to start part 2.
Hey Greg, how are you? Good. Yeah. Yep. Yep, I can hear you. Yes, I can hear you. Yep. Yeah, we're on the time lapse. Um, so, yes, convincingly overall, didn't he? In the end, like Like, well, I just think in the end, he did a good campaign. He had some good people around him, you know, and I think that's what came through. He stuck to those things we've talked about in the past, basically, of, you know, the economy, the border, and oh yeah, the tariffs, you know, the building.
It wasn't. I like to speculate as to who's going to take what post. You know, I have an idea. I think if I could make a guess, I think he's going to make Tulsi Gabbard the Secretary of Defense.
All right.
Because she's in the military, she loves it. You know, she could be state, but I think Secretary of State will probably go to Vivek Ramaswamy. The guy's really likable, very intelligent, well-spoken, and articulate.
Yeah.
And
well, they've set themselves a big agenda.
Yeah.
You know, in regards to some of the commitments they've made.
Yeah.
So, you know, it's going to take a fair bit of work. You know, like, I think the silver will be on a big learning curve. Yeah, but hopefully they can sort it out. Greg, and not get into, you know, all sorts of issues. Yeah.
I hope so.
Yeah, it'll be interesting times. Yep.
Yeah. It's very interesting, yeah. And Bobby probably, you know, will have something to do with either vaccines or getting our food health departments, the FDA, under control.
Well, I sent you that video where he was doing that talk before the election.
Yeah, I didn't get to see it yet.
Trump.
I didn't get to see it
yet.
And
that was basically talking about the health statistics on people.
Oh, yeah.
And you know, like, as he pointed out, he said, I'm not anti-vax, I just want to know that they're actually going to do what they say they're going to do.
Right. Right.
So, yeah, so that was really what his point was in that. Yeah, so, yeah.
I have
so other than...
Go ahead, keep talking.
Yep.
Keep talking.
Keep going. I said, so other than the election, Greg, what else is going on around the world?
Well, not much, you know. I mean, I really just can't believe, you know, from some of the you know, newscasts that I've watched online and stuff, how some of these people are reacting to losing. It's just crazy.
Yeah, remember,
I mean, you know, the Democrats don't get it. They don't.
No, but you got to remember the Republicans didn't get it either in the last election.
Yeah, I got a lot of questions about the last election. Do you know there were 20 million more votes cast in the last election than there was this election or the one in 2016? Where did those 20 million votes go?
Oh, where'd they come from?
In 2020. Right. Exactly. Yeah, I got a couple of videos to play for you, of course. You know.
Yeah.
So I'm getting that together right now. So until it's ready, we can continue to talk. I uploaded it. So, anyways,
but you know, look, I look at politics now as you can't get too embedded in one side or the other.
Right.
Right, because you just get totally disappointed. You know?
Absolutely. No, there's no doubt about that.
At the end of it, they all do some good, and they all do some things that aren't good.
Yeah.
No, that's the way I see it. You know, like, if you went through Biden's time, you know, as I heard the other day, when that war in Ukraine started, there was a lot of pressure on Biden to send American troops.
Right.
And he resisted it. Mm-hmm. He resisted it big time. So, you know, like, you got to give him credit for that.
Yep.
You see and hear him now. He's talking a lot easier, walking a lot better. So he must have been under a lot of pressure, you know.
Who's that now?
Beau Biden.
Yeah, oh yeah. Well,
you know, you hear him talking now. He must have been under a hell of a lot of pressure.
oh yeah.
Yeah.
Yeah. There's no doubt. Well, you know, the video that I'm going to show you as soon as it's done uploading is, you know, it's about, you know, those protesters that are the ones at Columbia University and all the colleges and all that stuff.
Oh yeah, over Palestine.
Yeah. Well, that turns out to be funded by George Soros. All of it. He's paying them like they busted it, and they found out all these left-wing organizations. Some of them were making like $5,000 to go there and cause damage and be a pain in the ass to the students that are trying to go there. It's like $75,000 a year to go to school there, or a semester, one of the two. I think it's probably a semester. Can you imagine that?
Yep.
And you're trying to go to school, and all these people, and they're not even college. They're just paid people that are paid by George Soros. What do they want? What is he going to get out of it? What are they going to try to find some way to keep Trump from being president? I mean, it's just I don't know what the I don't know what their plan is, but I don't really care either. I'm just glad he won because we can get back to normal again. You know what I mean?
Yeah.
Yeah, I got a couple of things to play for you here. I want to...
yeah, like I say, it's going to be interesting times ahead.
Yeah. Yeah, well, check this out. Check this out. This is about 7 minutes long, 8 minutes long.
And President Biden is expected to speak on the rise of anti-Semitism tomorrow, as anti-Israeli protests fueled by his top political donors continue at colleges across the country.
And as protesters are arrested after piling up around the country, cities are being left to pay the high costs of the police response.
We have team coverage. Madison Allworth is right outside Columbia. But first, let's go to Peter Doocy at the White House. Guys?
Good morning. We knew the money was coming from somewhere, right? The matching tents, the professionally printed signs, all the supplies. Well, now we know that they were, at least in part, indirectly paid for by some of America's wealthiest liberal families. Politico did an investigation. Part of it says President Joe Biden has been dogged for months by pro-Palestinian protesters calling him Genocide Joe. But some of the groups behind the demonstrations received financial backing from philanthropists pushing hard for his re-election. The donors include some of the biggest names in Democratic circles: Gates, Soros, Rockefeller, and Pritzker, according to a Politico analysis. The Gates Foundation says that their donations to these groups are not active. They have stopped. But not George Soros. You see in December, $300,000, November, $350,000, September, $250,000. Susan Pritzker, October, $3,300. Nicholas Pritzker, November, $3,300. David Rockefeller, in September, $10,000. That would be donations to the Biden. That is a list of Biden campaign donors who are funding some of these groups that are behind the anti-Israel college protests. And that is that some Democrats in Congress say that they are eager to vote in favor of a House bill that adopts the Holocaust Remembrance Alliance's definition of anti-Semitism as law. October, $3,300. Nicholas Pritzker, November, $3,300. David Rockefeller, in September, $10,000. That would be donations to the Biden. That is a list of Biden campaign donors who are funding some of these groups that are behind the anti.
George Soros is paying left-wing activists to head up camp out at colleges across America. I mean, it's just, why be that way? I mean, it's just to cause strife and shit.
The bearded freak who is a disgrace to his profession, who should be disbarred, who, of course, was going after Donald Trump, who raided President Trump's home. Jack Smith was behind the raid of Donald Trump's Mar-a-Lago. Jack Smith, turns out you can't actually prosecute a sitting president, and Donald Trump's your boss, bitch. Donald Trump's your daddy. Who's your daddy? coming. According to Fox News, DOJ is now confirming that Jack Smith will be gone before Trump is sworn in. They confirmed that Jack Smith's cases will all be dropped. Like Davis saying, and the probes of Jack Smith will open on January 20th. DOJ officials are evaluating how to wind down 2 federal criminal cases against Donald Trump before he takes office to comply with long-standing department policy that sitting presidents will not be prosecuted. 2 people familiar with the matter tell NBC. The DOJ cannot prosecute a sitting president. This is so delicious.
News about special counsel Jack Smith, this man right here. Donald Trump said recently that he would fire Jack Smith, quote, within 2 seconds of taking office. Well, we found out that he may not have that opportunity. The reason is that the Department of Justice, where Jack Smith works, cannot prosecute a sitting president. Fox News is told that Jack Smith will be gone from his post as special counsel, meaning the cases will be gone before Trump takes the oath of office at noon on January 20th. This is the documents case, though that was dropped already by Judge Eileen Cannon back over the summer, and it's on appeal, but also this case for Trump's alleged efforts to try to overturn the 2020 election. So given the fact DOJ policy says you cannot prosecute a sitting president, expect Jack Smith's cases to be done. The last case, and I'll end on this, is that Atlanta case that deals with the 2020 elections. That's a local Georgia case. We've seen over the last year how that has played out with Fonnie Willis, Nathan Wade. That has many problems, many different delays. So the bottom line for my story to all of you right now, Donald Trump's legal problems have essentially all gone away.
It should have happened from the very beginning.
James, the New York Attorney General, I dare you. I dare you to try to continue your lawfare against President Trump in his second term, because we're not messing around this time, and we will put your fat ass in prison for conspiracy against rights, and I promise you that. So think long and hard before you want to violate President Trump's constitutional rights or any other American's constitutional rights. It's not going to happen again.
We've been warning people on the show, Mike. This isn't the same Trump administration. Stop messing around. Don't rig elections. Don't illegally vote. Don't try the funny business, because we know the team this time, and they are not effing around.
This is the best part. This is the funniest one, Meg Kelly. I love Meg Kelly.
They don't have to. I give you stop 13. Take a listen. I'll watch.
We've been warning people on the show, Mike. This isn't the same Trump administration. Stop messing around. Don't rig elections. Don't illegally vote. Tomorrow? Don't try the funny business, because we know the team this time.
This is what it feels like. My head is fucking scared. Like, we're scared for our lives. We're scared for our friends. Like,
Oh my God.
I might wake up a motherfucking slave. I need to get it up. I need to get it up.
I am 48 years old, and I have
This is genuinely heartbreaking.
experienced anything like this. I never thought I would in this country.
Yeah, they're playing the music.
For a female black president. That is what I was worried about. Because the country is full of racist misogynists, men and women.
Yes, that's it, sister. I think it's a sister. Unclear.
Misogynist women.
I don't. It's not. They're not accepting laws well.
Wow.
It's not going well.
No, I think America is full of people that have mental health issues.
Yeah.
The beginning was great.
My advice to them is that conservatives saved all their asses. Again, to give them the right to hate everything that doesn't fit their crazy worldview. It's guys like this who fought at Iwo Jima and Quezon that went through shit like this, that fought and died for them, to even have the right to cry and whine and hate. You think the Chinese or Russians would have sympathy for them? They only care about themselves in the end, and the status quo. And it's them that keeps racism alive, the Democrats. They're crazy. They define everything in terms of color and race. Republicans don't do that. I'm not a Republican. I'm an independent, but I am a conservative. That was it. What'd you think? Andy, you there?
Yeah, but you Greg.
Yeah, what'd you think about that?
Yeah, well, it's just a continuation of what's, different things. All that.
Yeah.
So it'll be interesting to see how they go implementing and whether they can stay united enough to do it, the Republicans.
Right.
Yeah, so that's just more.
Well, it just happened to be the common sense thing to do this time around. Because, like Walt Thornhill says, common sense is really now uncommon sense. Hello?
Yeah.
Is there somebody else in here with us?
No.
Okay.
It's only you and I.
Oh, okay.
Greg.
So that's cool.
Yeah, I don't know what that's
well,
volume.
I'm gonna move on. Do you got anything?
Anyway, let's go back to Halton Arp and that.
What?
Because at the end of the day, we know one thing about it.
Yeah, I just wanted to see those people. I like watching them have meltdowns. That's funny. They're gonna be fine.
Yep, I agree.
Yeah.
Yep. Well, I agree.
Yeah, we'll have to chat it up in a little while after the show.
All right, we'll see if we can catch up a little later.
Okay.
Yep.
Okay, Andy.
Righto, Greg.
Okay. Bye-bye.
Bye.
Okay, folks, we're going to get back into part 2 now. I just wanted to have that little brief interlude to celebrate a little bit. I'll just show the left what they're doing. All right, let's go.
Yep, I agree. Yeah, well, I agree. Yeah, we'll have to chat it up in a little while after the show. All right, we'll see if we can catch up a little later. Okay. Yep. Okay. Righto, Greg. Okay. Bye-bye. Bye. Okay, folks, we're going to get back into part 2 now. I just wanted to have that.
This can really wake you up when you really start to look at things just using common sense or uncommon sense.
Imagine if every puzzle on Earth was solved, every why that we have pondered but could not answer for all our trying be mastered. Imagine if we all, God's ways, could clearly understand. Will this be reality, or is it just myth? Our thinking is like the streaming colored lights, flames flickering across the dark northern night. It was dark before we started thinking, and it will be dark again if we stop. Some claim that most questions in nature have been answered. Others think that we have only just begun asking. This is their story, the story of the universe.
Plasmas are found virtually everywhere. They're found in solid state matters at very low temperatures. A flame of a match, a fluorescent light is a plasma. Fire in your fireplace is a plasma. The aurora obviously is a plasma. The sun and all of the stars are a plasma. Lightning is a plasma. In fact, 99.999%, as Alfvén used to say, of all observable matter in the universe is matter in the plasma state.
A plasma is an ionized gas. It means a gas consisting of charged particles rather than neutral particles, which is the constituents of a normal gas. The charged particles are electrons, and atoms that lack electrons. So it consists of negative and positive particles that interact with each other by means of electric and magnetic fields.
The term plasma, as applied to electromagnetics, was first coined in 1923 by the Nobel laureate Irving Langmuir to describe the experiments that he was doing at the time. Basically, plasma consists of charged particles, the electrons and the ions or protons that we know in nature. It can also include charged dust. And in Irving Langmuir's experiments with the charged particles, he noted that they acted almost in a lifelike manner. They tended to develop cells. They acted very much in a way that indicated that they might somehow be related to life. And for that reason, he borrowed the term plasma from the blood plasma.
And plasma is like a society of individuals where all the individuals are interacting with each other through complex interactions like media, newspapers, television, and so on. And the normal gas is like a society where the individuals simply basically don't interact or interact at very short distances, very local communities.
The first effort to understand how plasma functions in the universe, to understand the plasma universe, was Christian Birkeland, who at the end of the 19th century wanted to understand what is the nature of the aurora.
Birkeland ble interessert I nordlyset I begynnelsen av 1890-årene, og grunnen til det var utvilsomt at han arbeidet med katodestrålerør. Et katodestrålerør, det et vakuumkammer hvor man satt på en spenning. Når lufttrykket blir lavt nok, så går det en strøm gjennom. På Birkelands tid visste man ikke at det gikk en strøm, for man kjente ikke elektronene. Men allikevel så trakk han en analogi mellom disse katodestrålerørene og det som foregikk på sola.
At this time, people were studying, for the first time, the nature of electrons. And you had, for example, the development of the cathode ray tube. The cathode ray tube we're familiar with. This is what powers our computers and our television screens. You have electrons accelerated, smashing into phosphorescent atoms in the screen and producing light.
Allerede før den tid så mente Birkeland at dette måtte være noe som var analogt med det som skjedde mellom sol og jord. At det gikk katodestråler ut fra solflekkene og traff da jorda og skapte nordlyset. Denne sammenhengen mellom sol og jord, den hadde ligget der en stund, fordi man visste at når det skjedde store eksplosjoner på sola, for eksempel den I 1859, som var aldeles voldsom, så fikk man en stor magnetisk storm etterpå. Og utifra det så trådte Birkeland den slutning at sol og jord på denne måten hang sammen, og at det var katodestrålene som laget dette. At det også da måtte være en elektrisk spenning mellom sol og jord som sendte disse strålene.
Birkeland reasoned that this might be exactly what's happening with the aurora. He basically felt that electrons coming from the sun would be channeled by the Earth's magnetic field into the atmosphere, where they would hit the atoms in the atmosphere, creating the fluorescent glow of the aurora.
Og der kommer det som den store idé han får, at strømmene kommer utenfra, fra sola, går ned langs magnetfeltet, kortsluttes I den øvre del av atmosfæren og går ut igjen langs magnetfeltet. Dette var en helt ny måte å tenke på, og det forbandt jorda med universet.
He wasn't content with just looking at this theoretically. He wanted to look at it experimentally as well. So he built a scale model of the Earth as a magnet, which he called a terrella, which was a metal sphere with a magnet inside. And he put it in a vacuum chamber, and he basically modeled the system of the aurora in the Earth's magnetic field.
Typisk for Birkeland var hans metodiske framgangsmåte i vitenskapen. Han angrep problemet med sol-jord-forholdene av mange forskjellige metoder. Han angrep den teoretisk. Han var en god matematiker selv, men han fikk inspirert Carl Størmer, en av hans yngre kollegaer, til å begynne å beregne hvordan disse partiklene beveget seg fra sol til jord. Han gjorde eksperimenter i laboratoriet for å se disse strålene, bygget disse Terella-kamrene med en magnetisk jord inne i vakuumkammeret, og hvor han da kunne se hvordan partiklene beveget seg fra sola gjennom jordens magnetfelt og landet på jordoverflata, da helst i polområdene. Han gjorde statistikk på dette, forholdet mellom sol og jord, og ikke minst, han gikk ut i felten for å observere tingene.
Birkeland's way of thinking was in direct opposition to what I would call over-specialization in science. He was doing a lot of different things, taking patents. He was thinking about cosmology and about small practical things. He was creating industries and so on. And I think the main power in his ideas when it comes to inspiration is in particular this aspect.
Han utvilsomt en av pionerene når det gjelder å bringe elektromagnetiske krefter og plasma inn i kosmologien. Og mange i dag har anerkjent ham som den pioner han var på det feltet. Og hans ideer om hvordan strømsystemene i jordas magnetfelt, i jordas magnetosfære det tilhører de klassiske ting i den moderne magnetosfærefysikk.
After his death, this whole approach of seeing the universe, as Birkeland put it, as filled with all sorts of charged electrical particles, basically fell away. He didn't have descendants, intellectual descendants who would pursue this avenue of approach.
Etter Birkelands tid så oppstod det en annen idé om at disse strømmene var skapt av rent horisontale, gikk rundt i horisontale baner i atmosfæren. Og det var først og fremst Sidney Chapman fra England som var talsmann for dette. Han tilhørte de som var rene teoretikere, hadde ikke gjort noen observasjoner selv.
Chapman's approach, which is similar to that of many of the Big Bang theorists today, was to take a purely mathematical approach and say, what is the simplest way to express phenomena mathematically? And basically, let's try and fit the phenomena into that simplest mathematical expression. Well, he found that it was very difficult to precisely define the sort of mathematical three-dimensional currents that Birkeland had hypothesized. Remember, this is long before the development of computers. So He found that the easiest mathematical representation was if the currents were all confined to a sphere that extended little beyond the Earth's atmosphere. And therefore he started to model things on this model, which completely contradicted the idea that these currents flowed from the sun and were trapped in the three-dimensional structure of the Earth's magnetic field.
Etter sin død i Tokyo i 1917 ble Birkeland stort sett glemt, også i den vitenskapelige verden. Men han må utvilsomt ha inspirert noen. Han var en inspirerende person. Han skapte aktivitet omkring seg, han sprudlet av nye ideer, og han inspirerte sine medarbeidere. Han inspirerte utvilsomt også noen i sin ettertid, og en av dem var Alfvén i Sverige, som grep fatt i Birkelands ideer om vekselvirkning mellom jordas magnetfelt og universet, og utviklet sin magnet- og hydrodynamikk, og kom i sterk opposisjon til Chapman på grunn av det.
Alfvén simply felt very much in spirit with Birkeland in this respect. Alfvén was an engineer from the start, and he liked to think about everything as an engineer and not in very abstract terms.
And he realized that it would be impossible for electrons alone to flow from the sun to the Earth. It had to be plasma flowing, because if the sun gave out a flow of electrons, eventually it would become positively charged, and that would prevent the flow from continuing. So his theory was that there were ejections of plasma from the sun. When these blobs of plasma hit the Earth's magnetic field, they would distort it. And if the distortion was enough, you would have things called magnetic storms.
It took many years before Alfvén's work in this area was recognized. And the main reason is that his work was so simple and so obvious that even the brightest people did not really realize the impact what he was doing.
He also developed at this time a more elaborated theory of how the electric currents concentrate themselves. Because of course when you look at the aurora, it isn't just a continuous glow. It's this fine sheet of filaments. And these filaments, Alfvén knew, occurred because of what's called the pinch effect, which is if you have currents flowing through a plasma, any plasma, the currents produce magnetic fields. The magnetic fields interact with the currents in such a way that the currents are attracted to each other. So if you start out with an even distribution of current, the current will filament. It will become tiny concentrated filaments of current pulled together by their own magnetic field.
The essence of magnetohydrodynamics is to boil down the very complicated motions of plasma particles in magnetic fields into a simple model that visualizes the plasma as a fluid that is electrically conducting. So it simply is a fluid where currents are allowed to flow, and the currents are interacting with the electric and magnetic fields and dragging the fluid with it. Another way to see it is that the fluid is dragging the magnetic fields with it. And this simple picture, to visualize things, had an enormous impact on how we could understand phenomena in space.
So he developed this pretty elaborated theory, which was compared with both laboratory experiments and observations of how the aurora works. But Chapman was still the dominant theorist, and Chapman completely rejected his theories, and in fact wouldn't even discuss it with him.
Det viser seg at det ikke er mulig å skjelne mellom de to ideene på rent observasjonsmessig grunnlag på jorda. Vi måtte ut i verdensrommet for å avgjøre hva som var riktig. Og det var det som skjedde utover på 1960-tallet, hvor man oppdaget at det faktisk gikk elektriske strømmer langs magnetfeltet, og man kalte dem Birkeland-strømmer.
Alfvén is generally credited as being the father of modern plasma physics. And he was, of course, awarded the Nobel Prize in 1970 for his extremely varied work in plasma physics. Now, by the time that satellites and space probes had begun to demonstrate that Alfvén and Halton and his colleagues' ideas about currents flowing through the solar system were correct, that such currents really did exist, and people began to accept that these currents, much stronger currents during the early days of the solar system, actually had a role in the formation of the solar system, in compressing gas and dust down to form both the sun and the planets. By that time, Alfvén had started to move on to larger scales.
Alfvén was very eager on formulating very bold theories for cosmology, and basically rejected the Big Bang model, and in this way came very much in opposition to the mainstream of cosmology.
Because he reasoned that if these currents flowing through the solar system could have formed the stars and the planets, then could not have much larger scale currents also be the way that galaxies themselves form. Some people have said that science is a method for asking questions of nature. And if that's true, then we can say the Big Bang supporters are people who won't take no for an answer.
Over the last 2 or 3 decades, the Big Bang theory has become increasingly more and more speculative. One expects from a scientific theory definite predictions which can be tested by observations. If the observations disprove the predictions, the theory is supposed to be disproved, and it should be modified or abandoned.
In science, we work from observation, from empirical observation that starts in the here and now and works outwards and backwards. The Big Bang starts from mathematical formulas, deductions, that start from the beginning of the universe and to try and predict it forward. This is the same mathematical approach, mathematical deductive approach, that led 2,000 years ago to the development of the Ptolemaic universe. The universe, of course, which was Earth-centered, with the planets going around the Earth, with the stars in a crystalline sphere. What these theories have in common is that they try and derive what should be the universe based on what perfect principles we can develop, what God should have made the universe to look like. And then they try to fit the universe into that perfect framework.
However, what has happened over the years is that whenever observations have come up which don't agree with the predictions of the Big Bang theory, the theory adds an extra assumption which is not at all tested, which is not at all resting on conventional physics, and simply assumes that that must be true.
The problem with that is that develops myth, not science. It develops a religious faith in which nothing in the real world, in the observable world, can contradict the faith in this structure, in the Big Bang. This undermines the entire scientific enterprise. The reason science has been valuable to human beings is because it allows us to predict nature in such a way as we can use nature in a predictable fashion in technology. To abandon this approach, which has served us so well, and to go to the idea that we can deduce, we can read the mind of God, as Stephen Hawking says, and deduce from perfect mathematical principles what the universe must be, is to abandon the scientific method.
There are those who would say that the story which follows could happen only in a dream. Regardless of where it could happen, this is the way it did happen in this rather strange and out-of-this-world office. Whitey is entrusted with the records of good salesmen. Red, the other kind. Now it seems that Red and Whitey never see eye to eye on matters. Naturally, this leads to many arguments.
I am the door. By me, if any man enter in, he shall be saved. There is only one door to heaven. People would have us believe there are many doors to heaven. No one can enter with a heart of unbelief. Only a heart that believes will have entrance there.
I'm going to keep a pretty close watch on these guys.
And so will I.
This idea of the Big Bang, which did originate at the beginning of the 20th century, the reason why it is so widespread nowadays is that it has a deep connection with the biblical creation. Instead of saying that the universe was created by God like 4,000 or 6,000 years ago, they now say it was created 10 billion years or 20 billion years. So for most people, and also for many scientists, they see a connection between this creation which comes from the Bible and this scientific point of view.
In 1952, in August 1952, we had a meeting of the International Astronomical Union in Rome. And we were received by the Pope. The Pope was then Pius XII. And Pius XII made an address to the astronomers. And this address was very clear. He said, oh, the Big Bang is the fiat lux, and how beautiful is the astronomy, how it proves that the greatness of etc., etc., etc. And I've been always sort of an heretic in all that sort of things. I don't believe in any God. And having the fiat lux and the Big Bang associated each with the other made me suspicious from the very beginning.
Nowadays, the majority of the physicists and astronomers, they believe and they work with the point of view of the Big Bang, according to which the whole universe did originate out of nothing, like 10 or 20 billion years ago, in a fiat lux, in a moment of creation. There was nothing before, and then the whole universe did appear and then begin to expand and to grow, and our galaxy, our life, came out of this great explosion in the past. But I myself, I had always problems with this point of view, because they are somewhat against the principles of physics, the most basic principles of physics, which are related with the conservation of matter and conservation of energy.
I forgot completely about the Big Bang because it just didn't interest me to look in those distant things of which the physics was rather vague and difficult to observe. But let's face it, in all the story of astronomy, for years and years and centuries, the progress came from new observations. And from confrontation of those new observations with past theories, contradictions, sometimes no contradictions, sometimes just a confirmation, but most often the contradictions led to new progress, to change in the theories.
In standard Big Bang cosmology, you have what I call a series of epicycles. The Greeks used to have epicycles, which are known as circles whose centers move on other circles, whose centers move on other circles, in order that they could correctly describe the position of a planet at any given time. They found that in some cases they had to introduce many circles before they could get anywhere near the reality. These epicycles are the assumptions that have been put in ad hoc into the theory from time to time.
The way that the Big Bang has handled the cosmic microwave background is a very good example of how this process works. When the cosmic microwave background was discovered in 1964, this very smooth, even radio radiation coming from all directions at once, the smoothness of the microwave background was considered a proof of the existence of the Big Bang. Only a universal explosion, they argued, could create this smooth, even background.
Now this is not necessarily so. Actually, the 3-degree radiation, to me, has not a cosmological value. It is observed in any cosmology. In any cosmology, you can predict the 3-degree radiation. So it's a proof of no cosmology at all if it can be predicted by all of them.
There's no explanation at all of the microwave background in the Big Bang theory. All you can say for the theory is that it permits you to put it in if you want to put it in. So you look and it's there, so you put it in.
First one to use the term Big Bang was Edgar Allan Poe.
First of all, the temperature of the microwave background, basically the amount of energy, was not what the Big Bang supporters had predicted. They had predicted a much higher temperature.
So it was 50 degrees Kelvin that was being compared against the 2 to 5 degrees Kelvin from the steady state universe. Now, this may not sound like much, but in energy density, where we measure the absolute differences, the differences is 4 orders of magnitude, 10 times 10 times 10 times 10 difference. So there is an enormous difference between 50 degrees Kelvin, a rather poor indicator of what is happening in the universe, and 3 degrees Kelvin.
When you read the textbooks, they don't tell the whole story. They don't present these figures, 5 greater than 5, 7, 50, and then that they did find 3. So that's very strange how the textbooks, they hide a part of history.
And the temperature of the Big Bang proponents was rapidly readjusted from 50 degrees to 3 degrees.
But their theory could be adjusted so that the temperature becomes a free variable that is just taken as what was observed.
We have an observable universe which is made of stars, galaxies that are not very distant, and that's all, because the 3-degree radiation, I would even think that it might be local. Still not. And going beyond that is, I think, a wild extrapolation, whatever it is. And physics that we could imagine to be existing there is based on nothing, because we have no test for it.
Although Big Bang advocates claim the discovery of the cosmic microwave background radiation as conclusive proof of their theory, history actually shows that there is a long line of well-hidden predictions previous to those made by Big Bang theorists. Not only were these predictions prior to those of Gamow and associates, but more importantly, they were made without any need for an expanding universe, and with far greater precision. This shows us that observations such as the background temperature of space have no preference for one or another theory, and therefore may not be used as definitive proof of any particular model. The fact that a theory is able to describe an observation does not mean that the observation proves the theory.
This is Bob Wilson at Bell Laboratories. The noise you're listening to is noise from a radio astronomy receiver on the 20-foot horn reflector antenna. This is the original instrument with which Arno Penzias and I discovered the cosmic microwave background radiation in 1965. This radiation comes from all directions and has a thermal spectrum. It sounds, therefore, very much like the noise you would hear on an FM set or a TV set which is tuned to an unused channel. Unfortunately, only about 10% of the noise you hear is coming from the cosmic microwave background radiation. The instrument is contributing about 22 degrees of noise. The Earth's atmosphere is contributing another 4 degrees. Our Milky Way galaxy is contributing 1, and finally the cosmic microwave background radiation, another 3 degrees.
When you say that the microwave background is a perfect blackbody radiation, that means it is completely thermalized. The theory of blackbody radiation tells you that that is the ultimate state of radiation when all information of sources from where radiation came has disappeared. Because thermalization means that it's completely smoothed out, wiped out its sources.
One of the main things that people point to as confirmation that the Big Bang is a valid theory is its predictions of the abundance of the light elements. That this confirms that the theory is a good theory. But in fact, it doesn't. In fact, observations clearly contradict this prediction of the Big Bang. Big Bang predicts the abundance of 3 elements: helium, lithium, and the isotope deuterium, which is the heavy isotope of ordinary hydrogen.
Now, one of the conclusions from this particular hypothesis that you can make deuterium in the Big Bang was that the density of matter in the universe should not exceed a certain value. Now, over the years, in the 1960s, this seemed to be holding out. 1970s, it seemed to be holding out. But by 1980s, it had become clear that the universe has considerable amount of dark matter, which is not included in these calculations. Now, if you include all this dark matter, you exceed the limit that deuterium abundance has put. That means if you assume that all the dark matter is present, then you could not have made deuterium in the amount that is observed in the universe. So this was a way of saying that the Big Bang prediction was wrong.
To determine the density of the universe and see whether this is consistent. If the theory is right, the density of the universe determined from deuterium abundance, the one determined from lithium abundance, and the one determined from helium should all be the same number. There can only be one density of the universe. While actually that's not true. Again, these are gross contradictions, and yet again, it doesn't cause the abandonment of the theory. Big Bang theorists simply say, well, there must be something that we don't understand about the evolution of lithium, about the evolution of deuterium, and even though these predictions have steadily diverged over the course of time.
But what did the Big Bang proponents do? They wanted a way out, so they said that this extra matter, which is proving to be awkward to fit into the framework, has to be a strange kind of matter, which is often called non-baryonic matter. Non-baryonic matter is basically matter which is not made of protons, neutrons, and the kind of elements that we are made of here on the Earth, or which we see in the stars or in the interstellar medium.
Dark matter. What was dark matter? Dark matter was some matter that we don't understand, we don't know what it's about, we haven't observed it, but it isn't ordinary matter, so it doesn't enter into our equations about the light elements, and we can't see it as stars. But dark matter is 90 or 99% of the mass of the universe. This is what we call in science a fudge factor. When your equations don't work out, you just write in this little plus something. Well, in this case, this was a humongous fudge factor because it was 90 or 99% of the universe.
And you have to not only postulate that this matter has to exist, but it has to exist in quantities much greater than the amount you see of ordinary matter.
And I should emphasize that people have looked for dark matter. People have looked for dark matter since it was proposed 20 years ago. Axions, WIMPs, little particles that are supposed to be floating around in space that we should, in theory, be able to observe as they pass through the Earth. Dozens of experiments have looked for these particles, not one.
Mr. Love, do that with your checkbook?
Again, this should be a contradiction. The way science works, you make a prediction, observation contradicts it, the theory should be rejected. But that hasn't happened. And the epicycles don't end. There's a problem with dark matter, even theoretically. Even though we can't observe it, there's still a problem with it, which is dark matter slows down the expansion of the universe. So the length of time that the universe has existed, the length of time since the Big Bang, should be shorter than what's indicated just by linear expansion. Well, the problem is it's too short. The prediction of the cold dark matter theory is that the universe should be about 8 billion years old. Well, that's a big problem. We can determine the age of stars in our own galaxy, in the oldest globular clusters, both based on very well confirmed theories of the nuclear evolution of stars and spectroscopic observation. And the stars in our galaxy are 13 or 14 billion years old. So it's very embarrassing to have 14 billion year old stars in an 8 billion year old universe.
In addition, they went into dark energy. Now, why did dark energy come in? Because if you take the present value of the cosmological constant and the cosmological constant which came out of inflation, you find that they are not the same. Not only they are the same, but you have to find that the difference lies in something like 108 orders of magnitude. Now, can you imagine a physical theory getting the answers wrong by a factor 10 to the power 108? Yet, the Big Bang cosmologists very coolly accept this and simply put in another epicycle by saying that there is a dark energy which has changed over the time by this factor. So we have to accept that.
Dark energy is some force, again, unknown on Earth, unpredicted by any theory that we have validation of here on Earth, that causes an acceleration of the expansion of the universe. So as the universe is accelerating, and it's older than it appears on the basis of the dark matter theory, and it's 15 billion years old. So we solve the problem of the age of the universe by hypothesizing yet a third completely ad hoc epicycle dark energy. So now we have a universe which is 70% dark energy, 28% dark matter, and only 2% matter that we can observe through our telescopes and here on Earth. Epicycle is being piled onto epicycle. And in the process, what we call the predictive power of the theory is fading away to nothing. One of the most destructive features of the methodology of the Big Bang is that it conveys the idea that only experts can understand the universe. Only people versed in extremely complicated mathematics can understand the universe. That if dark matter, dark energy appear to be incomprehensible or even nonsensical, it's because you don't understand the mathematics of these complex equations. This is, of course, the argument of the emperor's new clothes. If you can't see the emperor's new clothes, then you must be either stupid or incompetent.
So this goes on, and we can find that the old Greek tradition of epicycles, which was even adopted by Copernicus and has been continuing in standard Big Bang cosmology. If we go by the history, the Keplerian orbits, which were elliptical orbits, very cleanly and neatly resolved the problem of planets. And the circles upon circles idea had ultimately to crumble down. Now, in the same way, I suspect that the Big Bang theory will collapse under its own weight of assumptions, and a more neat theory, neat interpretation of the universe will emerge.
Does this mean that the age of the universe is not what Big Bang theorists have implied? Could the universe be eternal after all? How much are cosmologists really able to know?
We are now in a stage which can be called a plasma universe. And we are simply not privileged to know what stage the plasma universe evolved from. We do not have privilege to that information. We do not know. We will never know. And this is one major difference between the plasma universe cosmology and the Big Bang cosmology that claims to be closing in on the final answer.
The universe described by plasma cosmology is quite different. Here we are talking about a universe with no beginning and no end, an infinite universe, continuously evolving, an evolution that is continuously increasing at an ever rapid pace. It is a universe in which there is a coherence between what we can understand in the here and now on Earth and what we can understand in the rest of the universe. A universe in which there is no real limit to our ability to understand more new phenomena. And a universe in which we can apply what we learn in the universe in present-day technology.
The basic difference between plasma and all other forms of matter, that is solid liquids and gases, is that a plasma produces electromagnetic radiation and also tends to filament. So that we would expect in a simulation, which is what we see, in an experiment, which is what we see, we would expect to see throughout the cosmos a filamentary structure that is a spaghetti of currents intertwining the cosmos.
We can use plasma theory derived from experiments in the laboratory, from the basic concepts of plasma instabilities, from Maxwell's equations, and from the well-known laws of gravitation, to describe and predict how the structure of the universe came into being and what that structure is. So the key question is, how could this structure come into existence? Now, in the Big Bang theory, the universe starts out extremely homogeneous, very smooth.
This was in direct contradiction to the plasma universe that insisted that the universe overall must be filamentary.
But what we have today is extremely clumpy matter. When I talk about these huge voids, the structure of voids, the matter inside the voids is less than 10%, perhaps less than a few percent as dense as the average, and the matter in the walls of these voids, where these filaments of superclusters of galaxies are located, is 10 or 20 times the average. So you have extreme clumpiness. Now, what's the problem for the Big Bang to explain this? There's a huge problem. There is not enough time since the Big Bang to form these structures. These structures are older, much older, than the time hypothesized since the Big Bang.
Now, again, in interpreting the observational information, we can again go to the laboratory, which we are privileged to diagnose in any number of ways, in any number of directions, and run any number of experiments, which you can't do with the universe. But we also turn to the supercomputer simulations. Now, what a simulation does is that it allows you to model the plasma, regardless of size, put in the rather few basic initial equations, and then follow the simulation through its various nonlinear stages and the different morphologies or shapes that the plasma will take.
In Tony Peratt's simulations, as the current spirals into the center of the galaxy, turns around and moves out along the axis of the galaxy. In that central area where the current is extremely concentrated, there seemed again the potential for violent events. And Alfvén and Peratt raised the question, couldn't this be a way of explaining the extremely violent events that occur in the center of galaxies that are known as quasars, in which huge amounts of energy are released in what, by astronomical terms, is a relatively small amount of time. That is, millions of years compared with the billions of years galaxies exist.
Initially, the time frames shown represent 1 billion years or so, but now we're going to carry it out for 10 billion years to see what happens to these double radio galaxies, or quasars, as the two filaments have evolved into. And you'll see that the tails start to elongate, and fairly soon you're going to start to see a spiral structure. And as we get closer to the 10 billion years, the end of the movie, you will see that we have formed the shape, the morphology, the shape of a spiral galaxy.
Now, Alfvén developed a number of concepts that were critical to the whole understanding of the plasma universe. First of all was the basic concept of scale invariance in plasmas. That means there are certain phenomena in plasmas that don't change regardless of whether you're dealing with a laboratory scale of centimeters or a solar system scale of millions of kilometers or a galactic scale of hundreds of thousands of light years. What that meant was that time scales the same way as distance does. So not only does this mean that the phenomena of the cosmos can be studied in the laboratory, but because of time compression, the phenomena of the cosmos are essentially transient phenomena. It's funny to think of a galaxy lasting billions of years as a transient phenomenon, but it's analogous to events in the laboratory that last only millions of seconds. Another way of putting it, the plasma universe is extremely dynamic.
It's not going to be hypothesis. We've moved further than hypothesis. We've definitely gone into the second lake, the analysis, and we're well towards the third lake. Now, we haven't reached the third lake, of course, and perhaps, well, you can't with the universe because you can't experiment with the universe itself. Now, of course, we, like Alfvén, his idea, indeed you can determine what's happening in the universe in an experiment, but as far as producing universes, well, we're not going to do that. So we're going to do the best we can in the laboratory.
The universe that the Big Bang envisions and the universe of plasma cosmology are very different universes, and they have very different implications, and they cohere with very different ideologies of what is happening here on Earth.
The Big Bang theory will collapse under its own weight of assumptions, and a more neat theory, neat interpretation of the universe will emerge.
It's one of those shows that I never get tired of watching because you forget things, you know? I mean, with so much of this that goes unresearched, I think Einstein could have set us back a couple hundred years. I'll be out in a bit. Let's see if I got anybody in the chat. Let's see. It's one of those shows that I never get tired of watching. Because are you in the Great Hall? No. Anyone there? So much of this I invited Andy back, but I'm in the hall. So let me see, I'm going to just send him a quick message. I'll be out in a bit. Let's see if I got anybody in. Alright, I think I'm going to play one more video. I kind of want to go 3 hours. So I thought we'd spend it chatting either with Neil. I know Shockwave is hunting. And Andy. But Andy must have thought that I just wanted him to do the one thing. I invited Andy back, but I'm in the hall. All right, well, I'm just going to come out and see you. Where am I at? Right here. Yeah, okay. There you are. Put the show on you here. No, not that one. That one. Yeah, there you are. How's it going, everybody? Might take you a couple of seconds to see me. I got Sir Rilnil, Frankie, Alfvén 79, Jamalama, Modern Maniac. Good to see you guys. Alba Witch Wiggler. I got a tradition here. I'll have to.
Your stream will stop immediately and you will no longer be live.
Oh. Okay.
Your stream will stop immediately and you will no longer be live.
Oh, well then forget it.
This stream can be accessed again from the manage list. Exiting.
Okay.
Your stream will stop immediately and you will no longer be live.
Alright, I'm sorry.
Stop
This
stream can be accessed again from the manage list. Exiting will not end a stream if it is currently live.
Okay.
A catchy title can help you hook viewers.
Alright.
When you create stream titles, it's a good idea to...
Sorry. I never got that before, ever. Oh, well. Stuff happens, you know. Let me see. I'm gonna find a video real quick for you. I'll be right back. If you want to say anything to me, just say it, and I'll be back in a second. Peter
woke this morning with an attitude. I looked at the headlines, put me in a real bad mood. Sitting here in limbo, trying to stay sane. The end of the summer and the coming with the blessed rain. I feel dirty all the way down. I feel dirty, baby, like this dirty town. Gave you everything on a silver tray. I could have been a fool forever, but I'm not made that way. And after all these years, I think it's time to say goodbye. Doing you a favor will not help you live a life. And believe me, you think I'm gonna be there when you call. You don't know me, you don't know me at all. I close the curtain, love confess. Baby, I knew better, but you were such a lovely mess. You took my breath away, now I want it back. You should have killed me, always look so good and black. And after all these roads we've been down together, I think it's time to say goodbye. Believe me, you think I'm gonna get down and crawl. You don't know me, you don't know me at all. Not at all.
But I think that they'd also, those ones that only have a hole in them, They're completely encapsulated.
Yes.
They don't seem to be on top of high ground. Okay, they're not the ones on the bedrock. They're the ones somewhere down the slope from the bedrock. Okay, and imagine the storm is so dangerous now that you're willing to sacrifice all your animals. Okay, because this is what you have. I mean, if you're moving from place to place, you're probably moving with a herd. Okay, but you're now saying, I'm willing to squeeze in this hole with my family and everyone that can get in here, so that we now have a Faraday cage around us. Right. And all these animals, we just have to say they're going to fucking die. Yeah. I shouldn't have sworn. I apologize.
Oh, no, that's okay.
But I mean, I just picture how dangerous that would be. Because as you know, lightning can kill a herd of caribou, just like boom.
They do. Yep.
And the larger the animal, interestingly enough, the worse this effect is. It's called step voltage. It's something that, do you ever hear about the idea of jumping out of a car with both feet if it had something on it, like a live power cable?
No.
Well, you don't step out of the car. You don't want to create a current pathway. Well, in a lightning strike, it raises the voltage, or it raises the charge of a particular area, and that charge dissipates along a curve. And if there is a sufficient voltage between the front of the animal and the rear of the animal, the legs,
I see.
It creates a secondary current through the animal, which kills it.
I see.
So it's much harder for a human being to die because we stand up.
Yeah.
Now, I mean, we could get hit. Okay. Don't get me wrong, but we're not creating unless we have a step going. Like if we have a complete step between us. That's why if a lightning hits on an area, it's only those people who have their legs spread apart that are going to die in that instant when it happens. It's not, it's not a sure thing either, of course, like someone could get hit right in the head, like,
yeah,
life sucks, but generally speaking, and I picture this is what these things were for. And I base this on the decaying instances of electrical phenomenon in our atmosphere as time has gone on.
Yeah.
Such as St. Elmo's fire or electric fog, other things like that. That basically the lightning is just not as powerful as it once was.
Yeah.
I mean, sure, it's a powerful lightning bolt, and yes, it scares the dog. Yes, this is scary. Yes, we admit this, but it's not. We have to seek cover now. Like it's huff, puff, blow your house down type lightning,
Yeah.
Like, and these people, we gotta understand, we're living in, these people were not living in the same places as they were, like in Egypt or something, or Babylon, where they had walls and everything to protect them now. They're just living in, wandering with their herds and farming and so forth all over Europe. And these people were still able to erect these things knowing full well of their use.
Yeah, I was just noticing there's a dolmen in Minga in Spain, and it's the largest known dolmen found, and a 19th century archaeologist found skeletons of several hundred people inside. It's pretty huge, yeah.
But dolmens are often considered to be the entire pile of rocks that were on top of these rocks.
Mm-hmm.
You see, and I don't buy that. I think that they were covered over later because they were holy sites.
Yes.
Just like Göbekli Tepe was covered over.
Right.
They covered over. They went like this and turned into a shrine, like a pyramid.
Mm-hmm.
Like a holy place where they could go bury their dead.
Yeah.
Because it was very important to them. I mean, what it's. If you think about it in terms like this, a place where a murder was committed long, long ago is still a haunted place by the locals.
Yeah.
years later. And the same goes for holy places, even though they have no real reason why they were holy. Some are because they were depictions of the god in the sky, like from Stonehenge all the way to that beautiful mound in Ireland, the Grange Mound, the one that looks like. Anyway, I can't. But that's also a depiction, but a different type of depiction from a different era, much closer to like the ring around Osiris, with the snake. Closer to that, maybe from a different time period, but still closely related. But when I see that type of work, it's no doubt to me that these people kept trying to get there, like to head to this thing in the sky. I could see it being very well. A lot of them didn't come back. I mean, you can get to Greenland, and then, but eventually you're going to be underneath this thing, and it's eating the high mountains around you.
Yeah.
Okay. You're going to die.
Yeah.
If you keep playing this game, eventually you're going to get hit with something, right?
Yeah.
And there's evidence that they did. They went all the prehistoric man went all the way to like the northern tip of Greenland, trying to get to this thing. But it's like they were trying to walk to another world.
Right.
The illusion that we could walk off the world is because of the edge of the world is because of the rings idea. We were seeing them. I mean, almost everybody that we consider to be ancient history was seeing them from the point of view of the Northern Hemisphere. So it was like looking down at rivers. If you look too far to the north, you were going to have a stairway or river to the sky going up the North Pole, or a pyramid to the sky. Like, I think that now that to me that's the peaceful time. And if that's the peaceful time that actually existed, then that's when they had the best chance of developing an actual worldwide culture at that point. The more that you look, the more that it looks like there is a surprising amount of evidence for this. Like, not just in the giant stones, because I mean, we could say that the primitive people, even they could use a saw or whatever. Let's berate them and even say that. But some of the stuff that they managed to pull off, besides their obvious, astronomy and stuff like that, and mathematics, was how some of the structures look like they were built to take electrical forces into consideration. Like, why else would you put all these metal clamps to connect every single stone together? I mean, you're pouring liquid metal to connect rocks together electrically, because there's no other reason. I mean, you could just basically put a divot of stone and create the same effect, right? To lock the same thing into place, but they didn't. They used metal. And they were trying to make sure that every single block was connected to every other block, which means that if you had one of these around your city would never get hit in the middle. It would always get hit around the edge, because it'd be a Faraday cage.
Yes, I see them. Yes.
Yeah, they would use the world over. Like everywhere from Egypt, everywhere use those metal clamps.
Bolivia, Japan, Egypt, Greece, Tunisia, Italy. I see that.
I think that's
very good.
And that's a solution to a problem we don't have anymore. You see what I mean? And so that tells me that they were building for severe electrical events, like just basically like nothing more than giant thunderstorms. Okay, but I mean, they must have been, the kind that you would picture you know, like in some movie somewhere, the lightning bolt comes down and blows a tower up,
Yeah.
you know, or something. And you're like, my God, you know. But let's be fair. The last two that I know of are from Rome. The most recent ones. There's the story of, there's a lake north of Rome, and it was the main Etruscan city. And there was a 5-mile wide lightning bolt that came down from the heavens and destroyed that entire city.
Wow.
That's what the Romans say. I'll leave it. I don't know if they're lying. Although there is one more interesting account from the city of Portus, which Portus is Rome's port. It's literally where we get the name port from. But anyway, it's a ship fully laden was setting out across the sea, and it got hit with a lightning bolt from the blue and exploded.
Yes.
Just one, a bolt from the blue. So that was like no clouds in the sky, just boom. So that's how bothersome this must have been even then. And that was just 2,200 years ago or something. So I think if we keep going back in time, that these were worse and worse and worse. This is after the time of relative peace. Not that the pyramids were built at that time, because we know that they used smaller stones and may have used concrete and a few other things, and reused some stones inside the pyramid as well, and used some heavy gearing systems to seem to get these stones into place. So they obviously seem to be struggling, if you know what I mean. They're intelligent, working hard. I'm not pissing on their cornflakes here. I'm just saying that they certainly are not the same people that built the Assyrian.
Right.
Which is pink granite and cut, you know, with giant saws, you know, and beautiful. So it's clear that the Egyptians had a flaw, and one of their flaws was they worshipped the divine electricity, I think. They called it the divine waters above, or whatever you called it. Because, you know, the aurora would have been seen day and night some places probably. It looks like, and if you've ever seen the aurora, it's the green kind. Looks like water.
Yes.
So they used to say, well, they still say the upper and lower Egypt, but no, they mean Egypt was on the ground and the waters above were literally the waters in the sky. And it seems so painfully obvious sometimes when you think about it now.
Yes, but they still don't get it. Mainstream, they just don't get it.
Well, you can't blame them. I mean, if I was them, I wouldn't believe me either. I mean, I would like to think of myself as being more open. I would like to think, and I would like to think that if I had Neil deGrasse Tyson and Bill Nye the Science Guy in front of me, and we were just having beers at a bar, that we could talk through this, and I would make him walk out of the room going, you know what, I'm going to look into this. That's some very interesting points you made. And that's what I would like to think that they would think like. As long as they realize that I'm not one of the things that would shut them down immediately, which would be a Bible thumper or a flat earther or something, you know?
Yes, I just don't understand why mainstream cannot even say the word electricity, it seems. Although they are getting better, they're taking baby steps.
Yes, but clearly not fast enough. They're going to end up, in my opinion, they're going to end up killing a lot of people. And we're going to have to rethink this whole Mars thing, because that's going to be like, that's a real test of your theories. You know,
for sure.
And you're putting it all on the line now. All of your ideas, all of your money, everything, people's lives. You know, will they make it? Will they grow food, and will that food actually be edible to them? Will it look like the same food as grows on Earth? Will a baby growing in a different electrical environment, which we know that the electrical pressures have a lot to do with the growth of the actual body of anything that grows in it. It could be horrifying even. I don't even want to think that, though. Like stillbirths and so forth, and other things like that. Not that I want to think of it that way, but it could be a very bad situation for them.
Well, my opinion is that mostly in the medical field, I think there should be more treatments for people on an electric basis, since it's electricity that holds our cells up, and our bodies are electric. Disease could be something from,
Technically, everything's electric.
Yes. And I heard that pathogens can't exist in a pH balanced environment. Positive would be acidic, negative would be pH.
No, it's reversed. Negative is acidic, positive is...
negative ions from the Earth are good for you. Negative electrons, that's negative, right?
Well, see, it all depends on how you get them. A negative ion is just an electron. And, but an acid is like, battery acid is like something that has a pH of like 0.5. Water is 7.
Yeah, our bodies are 7.4 pH.
Yeah, just a little bit alkaline. Yeah, ideally. And now I heard about the disease thing. I think that might be probably something from the Andromeda strain. But
no, Rife. You know Rife?
I do know Rife, yeah.
He was treating cancer with what do you call it? Ultrasound or something like that. And it was 100,000 hertz was killing cancer cells. He took 30 people in stage 4. You heard that story, right?
No.
He took 30 people in stage 4 that were hopeless and cured them. And for his troubles, he got thrown in a madhouse.
See, I mean, blowing up. I mean, we use that exact technique to treat gallbladder stones and stuff like that. Kidney stones.
Yes. Yeah.
That's how we get rid of it nowadays, by using ultrasound and resonating it till it explodes.
Yeah, the Rife machine was doing that. 100 to 300 hertz. That's pretty high.
No, it's 100 to 300 hertz is pretty low.
I mean, 100,000 hertz.
Oh, no, that is pretty high.
Yeah.
That's just on the other side, just on this side of infrared.
Yeah, you know that guy, that Bosnian pyramid guy, he was the one who was talking about the Rife machine. And he said that actually
I wrote
viruses,
to him actually once.
Sam. Oh, you did? He said viruses are shaped like a pyramid.
Some of them.
Yeah. And he was talking about the Rife and how you
It's also a question about whether or not viruses are even from here.
Yes, they could very well. Yeah, I know exactly what you're talking about. Tom Van Flandern had a theory that came from outer space. Velikovsky was on that too.
Yeah, same with the late Sir Fred Hoyle.
Yes.
Panspermia, his idea that dangerous flus came by every time, especially when 45 days after a conjunction between Venus, a new moon, and the Earth. I thought that was very interesting.
It is, indeed.
I wonder if, I guess we can't really judge now, because with the artificialness of COVID strains, or the original COVID strain, probably.
It's funny, the COVID virus resembles a star to me.
It is. It's all coronavirus is actually, the only difference of a coronavirus, I think, is its feet. The little feet on it look different. They're all a big ball.
Yes. Yep.
And they're almost all respiratory, I think.
Yes. Yep. They are like SARS. Yeah.
Yeah. But anyway, I'm not really an expert on that for sure. But
no, me neither.
I'm very interested in times when it's said that horrifying things came from the stars, like after comets and stuff. That seems to be another thing that might have been a worse thing in the past too. Well, of course, we've heard the story. I mean, in fact, literally, the word disaster, if you break it down, is literally the word bad or dis, and aster, which means star.
Yep. Yep.
So it's just a
bad star.
Yeah. Mm-hmm. That's what a disaster is a bad star. So that's how bad comets were to them. And imagine what that must have been like some of those things coming down. They would explode at a distance, but still it would be wouldn't be unlike a nuclear bomb in some cases. I mean, just look at Tunguska. I mean,
yes. Wall has a pretty good theory on Tunguska that it was taken out by a thunderbolt.
I agree.
Yeah.
In fact, I did a presentation on electric geology. I have it on the Electric View. You find their specials there, and it's the electric geology toolkit. One of the things I talked about was if a Tunguska-sized boulder came in, it would have, according to witnesses, but also scientifically, it should have a giant beard coming off of it of streamers reaching down to the ground,
mm-hmm.
trying to make a connection. And that's why they said when it came in, it looked like a pillar of light. And finally, one of those pillars, one of those beards made a connection with the ground at some point, and that would have been one heck of a thunderbolt. That's 20 megatons.
No doubt about it. Yep. Nuclear. I hear H-bombs short out the Earth's electrostatic field.
Well, I think that's short out is a strong word.
Yeah, well, that's what Dollard says. They affect it in some way.
Oh, they certainly do.
Yeah. So you could say nuclear weapons are just an ultra-electric kind of a weapon.
They literally are.
Yes.
By what you do is, like, they're basically stealing so many milli-electron volts out of each atom.
Mm-hmm.
When they do a chain reaction, and that amount, it just that percentage that they're taking out, each electron volt out of that equals billions and billions and billions and billions of volts that it just shorts and explodes.
Yes, and an X-ray machine contains an anode and a cathode. It must just shoot supercharged particles through you.
It does, literally.
Yep.
In fact, it's just that they're because of their frequency, they manage to go between everything but bones. That's really it. And that's why we need a piece of film to read them.
So gamma rays would be a certain sort of EMF wave then?
Yes, except that usually when you hit a certain point, like anything above light begins to push into stuff that can ionize.
Yeah, and that means glow.
Well, it can knock atoms. It has enough energy to knock atoms out of place in your body and knock DNA out of place.
Right.
As it passes through you.
Mm-hmm.
And that's what is the scary part of a lot of that.
Yeah, cosmic rays.
Well, luckily we have the Earth's shield. A lot of people were talking about, oh, the Earth's magnetic field is weakening, and I'm like, it's not gonna. Look, even if the Earth's magnetic field overall drops to zero, the currents that power the magnetic field are still there. And the only thing that's happening is that the compass needle is now pointing in another direction soon. But that's the overall field, not the individual fields that make up, say, the jet stream or all the currents in the ocean, or none of those are going to stop.
Right.
So we're going to still have lots of electromagnetism around us, and 2 meters of water shielding, which is the atmosphere. So still, I as much as people might be worried so much, don't panic. Computers might have an issue, but I don't think it's going to destroy your power grid or anything.
Now, what about the poles wandering? Is that a concern?
Well, it's wandering because of what I said before. It's a concern if we were a giant spinning magnet, which we're not. We are the overall electric field wandering, or magnetic field wandering, is because of the fact that the southern pole, which right now is the strongest pole, is getting weaker and is becoming linked to the is basically going to get weaker than the northern pole, and it's going to cause all the compasses to flip. But there's a current moving in the North Pole and in the South Pole, and then it goes out along the equator or the ecliptic, and it's connected by a bunch of plasma bridges, we'll call them, or plasma tubes coming up from the ground that connect to these basically to these Van Allen radiation belts, and that is where we store our electric energy for the planet. And also along the surface, of course, but any excess usually gets stored up there. That's why when we get hit with massive EM fluctuations from the sun or blobs of plasma or anything, what tends to happen is that we just get another belt as it processes all these electrons. Electrically speaking, we're just a little load on a circuit. So, and it's going in the poles no matter what. It's going in the North Pole and the South Pole, but because it's going in fast or stronger at the South Pole, that makes, which is our geologic, or magnetically speaking, that's our North Pole. I know that sounds strange, but because the South Pole of your magnet points towards it.
Yes, that's true. Yeah, I know it sounds a little confusing, but the South Pole is actually in the north.
Yeah, like when we say the north magnetic pole is wandering, that's the southern pole of the magnet.
Yes. They're both wandering, according to.
They are, because they're getting more and more imbalanced, and because this would sound crazy if this was all coming from inside the Earth. Mm-hmm. We could be using this and going, the poles are wandering. This must mean the wobble of the mantle and the blah and the blah and the blah and the blah. I don't think that at all. I think what's happening is that it's coming from the outside, going in and out along the ecliptic, and the overall strength of one over the other determines the magnetic field. But even if our compass just starts spinning around in circles and is just perfectly at zero, okay, it can't tell where north is anymore. Mm-hmm. All of those currents would still be traveling, and all those magnetic fields would still be generated. They would just be canceling each other out on the north and south poles, respectively. Okay. See what I mean?
Yes.
But it's still there. It doesn't go anywhere. That's the part that people who don't know this sometimes get confused with, and they get doomsday.
Yes.
I'm like, no. The load on the circuit can't stop.
Right.
Okay, because there's no situation in which, unless the solar wind stops. If the solar wind stops, then yes, our magnetic field will completely stop. Okay, it's quite possible that would occur. But as long as the solar wind comes out, or as long as the sun is still shining, we should have a magnetic field.
Yes. I think I read from Don Scott's website that the solar wind did stop for 3 days once.
The solar wind stopped at a particular. Well, number one, it probably didn't completely stop, but it probably decreased greatly.
Yeah. Yes. Now the sun has been acting up lately. It's just it's kind of in a weird phase, but you couldn't tell it by the days and the heat and all that. It's still the same. It's crazy how the sun operates, you know.
Well, that's because a lot of the people who are basing a lot of their theories on, as much as I might debate the reason for climate change, I'll go with the evidence. The evidence seems to me that we're not causing it. However, that said,
No, I don't think so either. I think it's something with the sun.
that I agree. That said, however, if you guys want to make things prettier and end pollution, I'm not going to stop you. No, if you're going to make it better for my kids, I really can't argue with that as long as it's not, overly ridiculous.
Yeah.
But again, one of the things that comes back when you're talking about that is that all of the planets increase in temperature. So I'm pretty sure that Buicks in Delaware are not affecting the climate of Neptune.
No.
So something else is.
Yeah.
And the reason they say it can't be the sun is because the luminescence of the sun didn't change. That means the brightness of it hasn't changed.
Mm-hmm.
But that's the only power they have coming from the sun. That's I think, the problem right there.
Mm. Yeah. Now, as long as the sun is a positive body, is the anode, then it will continue to be the sun, correct?
Well, there's a lot of debate on why something becomes a sun and why something doesn't. I would like to think that it has a lot to do with nuclear reactions.
Mm-hmm.
And nuclear reactions tend to the last reaction of material that is not, that you can no longer react anymore, is iron.
Mm-hmm.
So basically it goes through all these reactions until it gets to iron and stops.
Yes, but you don't really believe in a nuke core center, do you?
No, but these reactions can still happen on the surface, like it's being cooked.
I see, yes, yeah.
And getting an iron shell on it. And the reason I'm thinking it's getting an iron shell, one of the things that iron does more than anything else is it actually compresses magnetic fields.
Mm-hmm.
Therefore, it pulls more electrons towards it.
Mm-hmm.
And it ends up with a giant magnetic field, which the sun has, highly ionized, and giving off an electric field.
So what do you suppose it might be that would first be, the first body to attract it to be a star? Do you think it would be the largest body in the system?
Yes.
Yes.
Exactly. That's all it is.
Yes.
I would think that if the sun disappeared, then and we didn't blow up.
Yeah, right.
Okay.
Right.
So just say the sun disappeared, then I would see all the gas giants would begin glowing like crazy, because they would suddenly be having to deal with the addition of processing all the electrons that the sun used to, because the circuit is still there.
Yeah.
And just because you remove the largest load doesn't mean all the other loads suddenly disappear.
Is there ever a danger that the circuit would disappear?
Yeah.
Yeah.
Like the sun, the sun is attracting a lot with its magnetic field, and we're stuck to the side of for lack of a better term, we're stuck to the side of a space tornado. Okay. And we might have used to be in the middle of it, closer to, and the sun might have been brighter. I don't know. I don't know any of these, or we could have been orbiting Saturn, and Saturn was closer to it. Who knows? This is too far back for me to judge that. But when we would be seeing the where we are now, we see ourselves right up against the wall of the local chimney. And we are like a little wart on the side of it.
Yeah.
A bump on the tree. You know, and I think that beyond that, there's one attached to the side of that.
Yeah, the sun is
the
a
side of
powerhouse.
us,
Yeah.
which is Proxima Centauri, and it's 4 AU out from us, from this chimney. So it's like we're sitting on certain layers inside this chimney.
Yeah.
And I think that we're sitting on the Birkeland current that's powering the sun. And because of the magnetic field, of course, it pulls in all the electrons in the area. And we drastically underestimate how many electrons are out there. If we only have 1 electron per meter, imagine how many electrons there are in 80 astronomical units.
Yeah. Yeah.
And then times that by, what is it, 2 pi r? No, wait, I have to do it in area. So anyway,
Yeah.
the point is that that's a gigantic volume of electrons, and they would all be moved by this magnetic field that the sun is creating with all this iron that's on it.
How much iron is on it, do you believe?
Well, I think it's entirely encompassing the surface.
The surface, yeah. I was going to say, so it's a solid surface, but you're saying it's probably made of iron.
I would believe so.
And that while it's being the sun, it's generating this iron.
Yeah, it's going through the nuclear reactions as it would in nuclear fusion, and but it's all at the surface, and that's what causes. That's why we have no. When we look at the sun, we're supposed to see neutrinos coming from the center of the sun, but we find none. We never found any, because that's a fault of their theory. Because the reaction is not coming from the center of the sun; it's coming from the surface.
Yes, that's right. That's what I think too. So if the sun were to ever go out, it would be a gigantic iron body just floating in space.
Well, yes, but it would never go out.
No, I wouldn't think so. But as long as it's getting feed.
As long as it's being fed, yeah. And even if it was floating through space away from the galaxy. Okay, I know that sounds totally crazy, but it's quite possible for it to still go into low into a glow mode and completely encompass our planets again, like it was back under Saturn.
Yes, I see.
And then we'd have purple skies again.
And it's interesting to see the stars that are in the sun's wake, you know, where the sun's been, other stars are. So that area is obviously still getting juice.
Oh, yes. It looked like well, yeah, in fact, there looks like there was an explosion sometime in the past. And this was witnessed by man, so much so that it was considered it was known as the whirlpool in the sky, and it was the Pleiades.
Oh, okay. I wasn't aware of that.
Yeah, it was the if you've ever seen a map, sometimes they have a map where they show the galactic plane, I guess you could say, and they would show you that on the map or something, just to show you like a star map, and then they would have another line that was off by 8 degrees, and that's a whirlpool. And that's in the area of the Pleiades. And so this means that all the stories of the whirlpool through Jason and the Argonauts and all that have to be recollections of some event that they witnessed. Because that boat went down through the whirlpool and came out the other side. And we must have saw, and today there's a giant belt of stars around that called the Gourd Belt, which is still expanding. So it's very interesting how we see things in the sky, and they must have been amazing. Could you imagine seeing a giant explosion? And it wouldn't. That's only like 200 light years away.
What's it called?
The Pleiades.
Yes, Pleiades.
Yeah, Pleiades, Whirlpool, Ancient, I guess would probably be a good search.
You need to share screen, Greg.
Huh?
You need to share screen.
They're close to wrapping this one up. I'm telling you, past hour and a half plus.
Oh, I've enjoyed it very much. Thank you.
I would love to have you come back. You know, we can still go for another 10 minutes or so.
Oh well,
It's
I'm
gone
sure
by
we've
so
gone.
fast. It's crazy.
Well, that's what happens when you get talking, I guess.
Andy, do you have any questions for Neil? We've been looking forward to this for long.
Yeah, we have. And it's good to hear you again, Neil. I used to listen to you, gee, it'd be a few years, time flies, it'd be a few years ago now when you used to have that, what was it? You'd be on YouTube, Electric Universe, something like that.
The Electric View, yeah.
Yeah, I used to often listen to you on that of the morning. And the same, you'd go 3-4 hours sometimes, no worries at all.
Well, go ahead, sorry.
No, I just said I was on it once and I loved it, but go ahead.
No, it is well, like I was telling him that it's clearly I'm just trying to get back in the swing of things after going through some tough times myself, but due to my injury. But you know, this is how you get back in the saddle, and it was really good to have a friendly face up there, someone who's going to throw me the softball questions, you know.
Yeah. Well, I'm definitely an ally.
It's not only that, is it, Greg? It's more. It's not like you're saying anything that's really
like the way you
offensive to
think.
anybody.
Yeah.
In some ways, different view to what they've ever heard.
Oh yeah.
You put it in the mix of all the things in life, and out of it you get bits. You go, yeah, you know, I reckon that's pretty right. That.
Yeah.
You know,
my people are going to love this. But I didn't really think about the questions. I just found it a very interesting conversation. When it's over, I'm going to think about 500 more that I should have asked, which is why we got to have you back again, Neil. It was a blast. It was fantastic.
I very much loved it.
I would.
Like we hear from Shockwave a fair bit, don't we, Greg? And
right.
You know, so we hear from Shockwave a fair bit. You know.
Yep.
Yep.
And trying to get him, he's doing good. Yeah, we had a show with him not too long ago. Yeah,
well, it was an impromptu one too, Neil.
But he always speaks highly of you.
Yeah, because he's the one who's often said that you hadn't been well.
Yeah.
So hopefully the corner's turned and you can get back.
Yes,
that would be ideal.
Yes. I'm all for it, man. Do whatever you need, you know, but I'd love having you on the show again. Can we do this again?
Well, I wouldn't see a problem not doing it. That'd be great.
Yeah, okay, that's cool, because first you're a new face, and second, people know you, and you're full of that knowledge that I love. So it was a fantastic time, man. I really had a great time.
Well, I'm going to just...
Can we pick up from where we left off next time, Pleiades?
Well, I was going to say here, because I'll
I'll
actually show you something.
Okay. Yes. Let's finish up.
No. I mean, right. I mean, I had a opportunity to just grab this photograph.
Oh, cool. Yeah, I'll put it in video.
I'm going to put it right into
chat
to you. Yeah, right in the tab here. If I can learn a link.
Yeah. Send me as many pics as you want if you want them in the show.
Oh, I just grabbed this one because I saw it, because I wanted to show you the, if you see where the Pleiades is.
Mm-hmm.
Oh, sorry, I didn't upload it. There we go.
Yes.
Right. So that right there is where the Pleiades is. So see that blue line? That blue line's the ecliptic, where the Milky Way is. So you see where Orion is right down there.
Mm-hmm.
The Pleiades is right there, and if you notice, they tried to do it some justice where it's straight on. But if you notice that if that disk was straight on, it would be about 8 degrees away from that blue line. See?
Mm-hmm. I see.
And that's the whirlpool right there, and it's always on maps. And in fact, according to this wonderful little thing that I looked up of messier objects, that it was the let's see, Babylonian astronomers knew the Pleiades as Mulmul, the star of stars. Aztecs based their calendar on the Pleiades, with the cluster's helical rising marking the beginning of the year.
Yeah.
Kind of messed up.
Yeah.
But I mean, just to give you an idea that they, like, it was an important thing, and we still, but like I've said about religion, in well-meaning they're trying to warn us about something they can't remember in a lot of ways, and it's the same thing here. All these cultures are saying, hey, the Pleiades, something really big happened there, and we're all going, haha, myth.
Yeah. Do you think the sun was ever part of the Pleiades?
No, but I don't know that for sure, only because I don't know.
They are G-class stars, are they not? Most of them.
I think they are, yeah.
Yeah, main sequence.
But it's just something very interesting, that how important they were to other people, and we still marked it on maps, that type of thing.
Yeah, the Seven Sisters. Yeah, they do rank very high in ancient lore. Yeah, I've read a lot about them.
Oh,
and you'd also think that our sun, Greg and Neil, you'd also think that our sun would have a mate somewhere. You know, usually on the electric, it's a pair, isn't it?
Yeah. Yeah, well, there's theories about that, you know. Degrazia's got Solaria Benaria, that its twin turned into the planets. And then you've got Velikovsky's Saturn theory, and then you've got, oh man, there's all kinds of them. You know, that happened. Like someone's trying to say that one star, what's the name of it? Sirius is the sun's twin, because it goes away and then comes back, you know.
Sirius is actually something very unique.
Yes, it is.
Sirius is along the chain with us.
Yeah. Yes.
In fact, it's the only star that doesn't rotate.
It doesn't rotate.
It stays with us as if we were both attached to the same cord.
Yes, we have something going on with them. I know that. I don't know.
Yeah, they're down the pipe from us, so to speak. If it was the Birkeland current or the local chimney, as they call it, then down below, Sirius is right in the center of that thing, and it's getting the full brightness. That's why it's one of the brightest stars in the sky.
Now, is there ever a time when Sirius might come so close to the sun, meaning the Earth, that it would cause cataclysms?
No, it's too far away. It doesn't orbit us.
It could never have influence in our system then.
No, in fact, it's stable because it stays the same distance from us
at all times.
It travels along with us along this cord, and it's going the same speed as we are. So all the other stars move in reference, except for Sirius. Sirius always stays with us.
Yeah.
And so do the Pleiades. Isn't that interesting? See, because we're all part of the same little group. And they're all attached to this thin, wispy pipe that it would look like a vein if you could make it go faster and speed it up.
Is Betelgeuse part of the circuit?
No, I don't know where Betelgeuse is actually. I do know that Betelgeuse is going through a phase change right now.
Yeah.
But that's why they think it's shrinking, and I'm like, oh, guys, really?
Yeah, I know. They think it's going to blow up because it was a red giant and it's going to be a white dwarf and that whole thing. But that's just the circuit. It's just a red giant.
Yeah, and the cool thing is that we might find a whole whack of planets in there.
Yes.
When it comes out, and if depending how long it's been like that,
mm-hmm.
Those bodies could be the perfect breeding ground for life.
The cradle of life. Yeah, that's what Wall calls them.
Mm-hmm. And he's not lying. I think that he's
right on.
I think he's got that nailed down, because
I do too.
The amount of water that would be generated just by the hydrogen interacting with the oxygen alone.
Mm-hmm. It would be a paradise, just like Earth once was.
Well, paradise for people who like it wet and dinosaurs.
Yeah.
But even the whatever they got in the so-called golden age, we'll call it I think I hate to say it, but that whole idea of giants always hits me a little hard, especially when you realize that the last giant cow was eaten in 1590.
Once existed, I do.
Well, I if they did, it just because we're kind of stupid. Unless we have animosity towards these things, we always think bigger is better. So bigger people are better. It sounds crazy, but I'm sure that they would do that.
Brain.
Well, yeah, but it didn't make them any smarter. They had to eat like crazy.
I don't know.
But
some geniuses existed sometime on Earth to build pyramids and things we still can't do today.
oh, I think that we could build the pyramids. I'm more concerned about what came before that. Like some of those beautiful stonework that they found underneath that one pyramid with all the vases and the thin, I mean, showing lathe work that was light years, we couldn't do it today. Beautiful stuff. It makes you question the whole anything. With that command of the stone, it seems like they could before, and then suddenly just one day it was all over.
All over. Yeah. Neil, it's been awesome. I got a live stream that I got to get ready for, and this one's going to go in the books, and we're going to have to get together again.
Oh, we should.
Absolutely.
It was fantastic.
It was.
There were so many things that were discussed that you can re-listen to, and then put them in, and then break them down and discuss the individuals of it. You know, you go back to art, creation, you talk about what we were just talking about, Birkeland currents. Each one of them's a subject on its own, isn't it?
It is, and you bring a little bit of, sometimes you have to go with the knowledge of the people that you're with, you know. And,
yes.
You know, I guess anyone who knows Grave J knows what a Birkeland current is.
They better.
At this point.
We talk about it quite a lot here. Yes.
Yep.
Yeah, the Electric Universe, I mean, the Thunderbolts group, I discovered them in 2014, and I was inspired so much that I started my own channel and started doing, you know, before that I was just wasting time, you know.
Well, it gives you something worth doing. And
oh, yes, definitely.
I hope that some of the things we have to talk about end up in the, like I basically have to put together a nice little presentation for the Detroit thing. Should I be able to go?
Oh, I hope you do, because I'm going to be there.
Well, I'm looking forward to it. It should be. I mean, like I said, I
haven't been officially invited yet. But.
With my back, I don't know. But at the same time, I'm like, well, you know, as long as I can, certain things can be achieved. I think I can pull it off. It's only for a weekend, right? So
right.
It's not exactly like, you know, if you can deal with the fact that every time I wear myself out, I'm just going to go, instead of partying tonight, guys, I'm going to go to bed. Okay. But besides that, you know, I'll try to party.
Yeah.
Anyway, guys, it's been great. And I hope to talk to you again.
Oh, you will, dude. We're going to have to hook up. I'd like to do this again, and soon.
Excellent. I enjoyed it very much.
Yeah.
Well, I guess I'll let you go then, and thank you so much.
You're welcome, and thank you. We'll see you again, Tim. Take care, man. Yeah, that was a fun talk. I'll be out in a minute. The Archangel. In the scriptures, the destination of the army of Sennacherib is said to have been caused by a blast, and a few verses later it is said to have been the act of an angel of God. The Talmudic and Midrashic sources, which relate that the army of Sennacherib was destroyed by a blast and scourge accompanied by a terrible din on the night following the day when the shadow of the sun returned 10 degrees, are more specific. The scourge was inflicted by the Archangel Gabriel in the guise of a column of fire. In the present research, it has been established that was the work of Mars. Are archangels planets? An old tradition dating back to Aeonic times had it that there are 7 archangels, each of whom is associated with a planet. The 7 archangels were believed to play an important part in the universal order through their association with the planets and the constellation. There is some variation in different versions in the angels assigned to the planets. In some medieval writings, Gabriel is associated with the moon, but in 1 or 2 with Mars. The following, however, makes the identification of Gabriel possible. Gabriel is connected with the foundation of Rome. The Jewish legend says that when Solomon took the daughter of Pharaoh to wife, the Archangel Gabriel descended from heaven and inserted a reed in the sea. About this reed, more and more earth was gradually deposited, and on the day on which Jeroboam erected the golden calves, a little hut was built on the island. This was the first dwelling place of Rome. Here Gabriel is cast in the role the Romans ascribed to Mars, that of the founder of Rome. Our assumption that it was the planet Mars which caused the destruction of the army of Sennacherib in the spring of -687 is implied also by rabbinical sources. Since the Archangel Gabriel is another name for the planet Mars, the ancient Jews knew the origin of the blast and the identity of the angel of the Lord, who destroyed the Assyrian army. Gabriel is the angel appointed over fire. He is also, according to Origen, the angel of war. Thus, we again recognize in him Mars' miracle. The rabbinical tradition says that the Assyrians of the host of Sennacherib, before they died, were permitted by Gabriel to hear the song of the celestials, which can be interpreted as the sound caused by a close approach of the planet. The words of Isaiah 33:3, at the noise of the tumult, Harmon, the people fled, should, according to the Jewish tradition as related by Jerome, refer to Gabriel, Haman being another of his names. The planet Mars is red, and Medim, the red or the one who reddens, is the name for Mars in the Hebrew astronomical text. One text says the Holy One created Mars, Medim, that he should throw them, the nations, down into hell. A few rabbinical sources attribute the destruction of Sennacherib's army to the action of Archangel Michael. Some ascribe it to both archangels. Who then is the Archangel Michael? The entire story of the Exodus is connected with the Archangel Michael. In Exodus 14:19, the pillar of fire and of cloud is called Angel of God. According to the Midrash, it was the Archangel Michael who made himself a wall of fire between the Israelites and the Egyptians. Michael is said to be made of fire. The Haggadah states, Michael was appointed high priest of the celestial sanctuary at the same time that Aaron was made high priest of Israel, that is, in the time of the Exodus. Michael was also the angel who appeared to Joshua, son of Nun. The celestial struggle at the Sea of Passage depicted in the familiar image of Archangel Michael slaying the dragon. Michael produces fire by touching the earth, and it was the emanation of this archangel that was seen in the burning bush. He has his abode in heaven, and is the forerunner of Shekinah, or God's presence. But as Lucifer, Michael falls from heaven, and his hands are bound by God. All these attributes and acts of the Archangel Michael lead us to recognize which planet he represents. It is Venus. The Archangel Michael, or the planet Venus, and the Archangel Gabriel, or the planet Mars, saved the people of Israel on two dramatic occasions. At the Sea of Passage, when the hosts of Egypt pursued the fleeing slaves, could be seen in the distance. The children of Israel lifted up their eyes, and behold, the Egyptians marched after them, and they were sore afraid. The sea was torn apart, and the slaves walked in the bottom of the sea, and reached the other shore. Their enemies were thrown high by the released tides, which fell down when a spark passed between Venus and the earth. 800 years passed after the Exodus. The Assyrian host, which a generation earlier had removed the 10 tribes of Israel to an exile from whence they never returned, invaded Judea with the express purpose of crushing rebellious Judah and removing him from his homeland and from the scene of history. A blast from the planet Mars fell upon the camp of the Assyrians and annihilated it. Those rabbinical sources which ascribe this act to both archangels were not wrong. Venus pushed Mars toward Earth, and thus both were instrumental in the destruction. The author of the apocryphal book of the Assumption of Moses knew that Venus and Mars are each as large as the whole Earth. Because of their intervention at moments when the national existence of Israel was at stake, Michael and Gabriel were looked upon as guardian angels of the eternal people. Gabriel is the Hebrew Hercules. Actually, the classic authors made it clear that Hercules is another name for the planet Mars. In the Gospel of Luke 1:26, Gabriel is the angel of Annunciation to the Virgin. In the Roman Catholic Church, Michael is the conqueror of Satan, head of the host of heaven, and first of the saints after Mary. End of subchapter.
Amazing how the meteorites keep falling on the enemy's head and not theirs too. You know, if it's an act of nature, it would be random. It doesn't sound like it's random at all.
Planet worship in the 7th century. In the Northern Kingdom, the process of disassociating the deity from the celestial object had not been completed when the kingdom was destroyed, minus 723 or 722, and its population was led away into captivity, from which they did not return. And they, the tribes of the Northern Kingdom, left all the commandments of the Lord their God, and made them molten images, even 2 calves, and made a grove, and worshipped all the host of heaven, and served Baal. 2 Kings 17:16. Only a few years after the deliverance of Judea from the hand of Sennacherib, Manasseh, son of Hezekiah, built altars for all the host of heaven in the 2 courts of the house of the Lord. 2 Kings 21:5. For he, Manasseh, built again the high places which Hezekiah his father had broken down, and he reared up altars for Baalim, and he made groves and worshipped all the host of heaven, and served them. 2 Chronicles 33:3. It was in the time of Josiah, grandson of Manasseh, shortly before the exile of Judah to Babylon, that a pure monotheism emerged as an outcome of the progress the Jewish people had made during its long struggle for national existence, on the one hand, and for purification of its concept of God on the other. And the king, Josiah, commanded Hilkiah, the high priest, to bring forth out of the temple of the Lord all the vessels that were made for Baal and for the grove, and for all the host of heaven. And he burned them without Jerusalem in the fields of Kidron, and carried the ashes of them into Bethel. And he put down the adulterous priests, whom the kings of Judah had ordained to burn incense in the high places in the cities of Judah. He put them down. That must mean that he whacked them. And in the places round about Jerusalem, them also that burned incense unto Baal, to the sun, and to the moon, and to the planets, and to all the hosts of heaven. 2 Kings 23, 4 and 5. The scriptures do not hide the fact that in Judea, as well as in Israel, the planetary cult was the official cult with the priest and with king, with many prophets and with the people. Thus Jeremiah, contemporary of King Josiah, says, At that time, saith the Lord, they shall bring out the bones of the kings of Judah, and of the bones of his princes, and the bones of the priests, and the bones of the prophets, and the bones of the inhabitants of Jerusalem, out of their graves, and they shall spread them before the sun and the moon, and all the hosts of heaven, whom they have loved, and whom they have served, and after whom they have walked, and whom they have sought, and whom they have worshipped. Jeremiah 8 and 2. And again he says, And the houses of Jerusalem, and the houses of the kings of Judah, shall be defiled as a place of Tophet, because of all the houses upon whose roofs they have burned incense unto all the hosts of heaven. Jeremiah 19:13. In the days of Jeremiah and King Josiah, a scroll was found in a chamber of the temple, 2 Kings 22. It is generally thought that it was the book of Deuteronomy. That's kind of a funny chapter, like Deuteronomy. I can't help it. The last book of the Pentateuch.
Pentateuch.
Of all the Pentateuch, the text of the scroll made a strong impression on the king. And lest thou lift up thine eyes unto heaven, and when thou seest the sun, and the moon, and the stars, even all the host of heaven, shouldest be driven to worship them, and serve them, which the Lord thy God hath divided unto all nations under the whole heaven. Deuteronomy 4:19. Thou shalt not make thee any graven image, or any likeness of anything that is in heaven above, or that is in the earth beneath, which is a passage of the Decalogue, Exodus 24, verbatim. If there be among you man or woman that hath wrought wickedness, and hath gone and served other gods, and worshipped them, either the sun or moon, or any of the host of heaven, which I have not commanded, then thou shalt bring forth that man or that woman, and shall stone them with stones till they die. Brutal. Gee. Thus we see the centuries-long struggle. You knew that it had to be wrath, because they're so, murderous. Planets don't go by and leave rainbows. Thus we see the centuries-long struggle for the Jewish God, creator and not an animated planet, itself a creation, being carried on the closing decades before the exile to Babylon, with the help of the book whose authorship was ascribed to Mars. When the people of Jerusalem were exiled to Babylon, and groups of refugees succeeded in escaping to Egypt, taking with them Jeremiah, they said to him, But we will certainly burn our incense unto the Queen of Heaven, and to pour out drink offerings unto her, as we have done, we and our fathers, our kings and our princes, in the cities of Judah, and in the streets of Jerusalem. For then had we plenty of victuals, and were well, and saw no evil. But since we left off to burn incense to the Queen of Heaven, and to pour out drink offerings unto her, we have wanted all things. and have been consumed by the sword and by famine. It is apparent from this passage that the population of Jerusalem that sought refuge in Egypt thought the national catastrophe fell upon their people, not because they had left the Lord God, but because in the days of Josiah and his sons they had ceased to worship the planetary gods of Manasseh, and especially the Queen of Heaven, the planet Venus. Of this remnant of the people that went to Egypt in the beginning of the 6th century, a military colony was established in Elephantine, in southern Egypt. Documents, papyri, of this colony were unearthed in the beginning of this century. The Jewish colony in Elephantine faithfully worshipped Yahu, and it's got Yahweh in parentheses, the Lord of the sky, because Yahu was a Chinese king, I think. Something, but it's Yahweh, yeah. They just spell it Y-A-H-U. The Lord of the sky, as the theophoric names of many members of the colony testify. Scholars were puzzled, however, to find on one of the papyri the name Anat Yahu, Yahweh. They were uncertain whether it belonged to a goddess or a place or a person. Anat is the familiar name of the Canaanite goddess identified with Athena in a Cyprian inscription. The historical facts revealed in the present research make the understanding of such cult easier. The dark tradition that it was the planet Venus that played such an important role in the days when the forebears of these refugees in Egypt left that land and passed through cataclysms of fire and water, sea and desert, was responsible for this synchronism of name. The Jewish people did not obtain all of its supremacy in that one day at the mountain of law-giving. This people did not receive the message of monotheism as a gift. It struggled for it. And step by step, from the smoke rising from the overturned valley of Sodom and Gomorrah, from the furnace of affliction of Egypt, I really like, as a ring to it, furnace of affliction. Well, and you're known from the deliverance at the Red Sea amid the sky-high tides, from the wandering in the cloud-enshrouded desert, burning with naphtha, from the eternal struggle, from the search for God and for justice between man and men, from the desperate and heroic struggle for national existence on its narrow strip of land against the overwhelming empires of Assyria and Egypt. It became a nation chosen to bring a message to the brotherhood of man and to all peoples of the world. End of chapter. What would you think of that? Pretty good, huh? Yes, I enjoyed it. I did. Thanks for watching. I hope that you got something.
Yeah,
Seems to me pretty bonus.
What's the night without a little
Velikovsky
Planets
to
were
kick it
kind of
off,
a lot
closer
closer
to
to
the
the
Earth. I think that's the point he's making. It's in everything they wrote. Please don't forget to like, share, comment, and do donate if you can. If you get something from it and want to give something back, I do understand. Everything I have online is free. Adios, amigos. See you on down the road.
That's going to do it for tonight. I'm going to come out and say goodnight. I love you.
Velikovsky. Worlds in collision.
Forget to have my mic on. I do it all the time. Well, that's going to do it for me tonight, guys. Just love seeing your names. You know, you've been around, you've been really loyal and coming around a long time. And I just love that. I really do. Thank you so much for coming. Rick Jones, John Eggman, Sir Real No, little promotion for you. Frankie, John Lama, John Bigman, thank you for coming. You guys looked like you had a really good conversation going there. Electrons of the solar system are planets. Well, that's a good, I like that. They are negative. All around it is a microplasma, plasma in dark mode. Excellent, yes. Plasma is highly mobile and condenses via two mechanisms, the magnet and electric fluid. I like that. Well, guys, IP 245, John Lama, love seeing your name, John Bigman. I guess that'll do it. Don't want to miss anybody. I know that Val was here earlier. Modern Maniac was here. Thank you for coming. And I'll see you next week, okay? I'm keeping them 3 hours so I can prolong it. I hate to let 56 guys down. That's a good number. I'm happy. But I gotta go. I'll see you next week, I promise. I'll be back. All right? Thank you. Good night. Well, guys,